Hello, I'm JW. This is part 2 of a webinar which was recorded on the 22nd of September 2020, and it covers BS7671 Amendment 2 Draft for Public Comment. This was published on the 21st of September, and it's actually remaining open for comments until mid-December 2020. So this is part 2, and this is a recording of a live event, so it includes the audio and the presentation slides. However, it does not include the chat and other comments made by other people attending. This is a continuation from the previous webinar, and in particular importance, this one covers the part 8, which is Prosumer's electrical installations. This is completely new as far as BS7671 is concerned, and something that's not been seen before, although it has existed in various other standards previously.
So, hello everyone. We're now sat on the 18th edition. We know we've been introduced to Amendment 1, and the only real people who've probably read it are the EV installer mob, very small, free to download, which is why it was white. So this webinar, for those who may not have watched yesterday, what we did is we went through pain and misery from when it was released yesterday around lunchtime, and chucked together slides and key highlight bits, having two screens, reading and getting migraines. So most of yesterday we had a headache doing this, but it was just trying to give you an advanced preview of our thoughts as a collective group of friends, and also allow you guys in the chat to engage and have conversations with us, because this is just as much your webinar as it is ours. If you're watching on YouTube, we always say the same thing as we did in the last one. You kind of lose half of the experience, without a doubt, at least. But yeah, we'll put this on there as just for record, and we always get asked to put them up on YouTube anyway. So we're now in the wonderful world of brown trouser alert, or brown cover alert, Amendment 2. So a couple of key dates. This isn't out yet as a formal document, and it could change. 28th of March 2022. So we've got till, is it 11th of December? Or have they changed that?
It depends. I mean, last night, it was yesterday.
It was last night. Last night.
Yeah.
It's now 11th of December.
I think it's supposed to be December, early December.
B stands for broken.
That was the agenda.
It's supposed to be then, once it comes out, you can adopt it straight away if you choose to, or you can give it a year, and then all installations designed after 28th of March 2023 are expected to comply in some form. So yesterday we went through parts 1 to 5. But we skipped a few bits out of 4 and 5, and we're just going to kind of go back into 4 and start where we were going to hit. We were going to discuss with Kirsty, but at the moment everybody knows this regulation. It's overvoltage control. Protection against transient overvoltage shall be provided where the consequence caused by overvoltage could result in serious injury to or loss of human life, or result in interruption of public services and or damage to cultural heritage, or result in interruption of commercial or industrial activities, or affect a large number of co-located individuals. Pretty much everybody there, let's be perfectly frank.
Yeah, we've returned to this a number of times, and that's always the outcome of a discussion point, isn't it? It's been worded like that to try to capture everything. 7
hours of podcast trying to make this in plain English. For all other cases, a risk assessment according to 443.5 shall be performed in order to determine if the protection against transient is required. We now know that risk assessment is very limited in why you would actually do it in the first place. If the risk assessment is not performed, the electrical installation shall be provided with protection against transient overvoltage, except for single dwelling units where the total value of the installation equipment does not justify. We also know that there is an IEC version of that, which pretty much once you do that, it's going in anyway. So this is the existing reg. Protection against switching shall be considered in case of equipment likely to produce switching over voltages. It's very important for this, and the reason being is it's been rewritten. And ladies and gentlemen, I give you part of the new regulation. It's now transient voltages due to the effects of indirect lightning strokes.
Well, we had this definition added, didn't we, which we covered yesterday?
We did, yes. Point. So strokes is a new term in the regulations, although it was kind of spoken about quite a lot by the IET. They just evidently didn't put this in. Now, weirdly, I don't like it when regulations start with notes, because notes shouldn't really form part of the regulation, or do they? Depending on who you speak to will have a different view. Note 1. For protection against transient voltage due to direct lightning strikes, see 443.1.1. And then note 2, the installation of SPDs is intended to provide voltage limitation in order to facilitate insulation coordination and protection against damage to current using equipment. That should say installation, I'm assuming, not insulation. That's a direct quote, by the way. So maybe a little typo there. I can't see how to provide insulation coordination. Maybe that's coming in the 19th edition. Who knows?
Wow. Yeah.
Protection against transient overvoltages shall be provided where the consequence caused by overvoltage could result in serious injury to a loss of human life. No change there. Then it goes to note 3. This includes electrical systems associated with safety services as defined in part 2. So
that's trying to tell us how to interpret that, isn't it?
Yes, it is.
That's basically what it's trying to say there. It's just helping us to interpret that.
So there is now also there's a new part that says significant. This is all new, by the way. That's why it's in green. Significant financial or data loss. Then it goes back to the old-fashioned, except for single swell dwelling units, for all other cases where the consequences of an overvoltage of atmospheric origin are considered to be intolerable. A risk assessment according to Regulation 443.5 shall be performed in order to determine if protection against transient overvoltage is required. We then go further along to note 4. A discussion will need to take place between the designer, the installer, and any other relevant parties, such as the installation owner and or end user. Well, I can tell you now, if anyone remembers the dime bar adverts Harry Enfield did, talking about surge protection in front of some end users you're just going to get them going, hey, what?
What kind of competency does it determine this discussion to take place?
Well, I can't see this being in the final version whatsoever. It's just nonsense.
You know?
To determine what considered is to be intolerable. So straight away, you could have someone who's not very confident going, no, I don't want that, because they're just thinking about cost.
Yeah.
Or in the case of the dwelling units, to determine the total value of loss. Guys, anyone who's watching this, and again, if Kirsty was here, would say the same thing. This needs a bit of commenting on. It needs to be in a clear English for electricians to take the ball and run with it and give them the ammunition they need to make the right decision.
I know there are experts like Kirsty involved in JPAL, but this is this kind of scenario where a discussion should take place with the designer, installer, and the other relevant parties. Sometimes that's the same person, designer and installer, and the only other party is a customer.
Yeah. Neil has said a socially distanced discussion. Absolutely. Protection against transient overvoltage is not required for single dwelling units where the total value of loss therein does not justify such protection. I think somebody's really tried to rewrite that, but it's still pants. It's still
this
rubbish.
thing about dwelling units and the total value it's still a load of nonsense, because any house or dwelling pretty much anywhere is going to have enough value in it to justify installing it. So it's not really an improvement here. It's just sort of taking the existing mess and shoveling it about a bit, and then coming out with something like this.
Well, there must be someone on the committee that goes, oh, sometimes you have an indirect lightning stroke, and the only thing that goes down is a phone or a modem or something that is not as expensive, and so they probably just keep throwing this back in as an example. Yeah, that's probably it. There's no other reason.
I think my comment was to you guys when we were discussing this was, it looks like different people have written it and they've badly stitched it together, like Frankenstein's regulation. Yeah. Note 5, in practice, most single dwelling units have current equipment rated to overvoltage category 1 and or 2 connected to fixed installation. See regulation 44361. This equipment therefore is potentially at risk from the effect. Just fucking spell it out, will you?
Yeah.
Come on.
Well, Jonathan in the comments has put, just make it mandatory and get on with it, because
absolutely, Jonathan Harrisburg, well said, that man.
That's where we're going.
It's very frustrating. Now, normally this is the bit where we would ask Kirsty to chip in and vent or agree or disagree, etc., etc. But I think what we'll do is we'll get her onto a future webinar. Dave, you can get her on in the future once this is settled down a bit and everybody's had their say and all the rest of it. So back into part 5, guys, because there was bits that we kind of didn't really cover yesterday. Labels. This is an existing regulation, hence the blue book, where an installation incorporates an RCD. An instruction notice shall be fixed in a prominent position at or near each RCD in the installation. The notice shall be inscribed in indelible characters not smaller than those illustrated here and shall read as follows. Now, we all remember the print-in faux pas, where they made them really, really big and it got ridiculous. And then they was like, oh, no, yeah, the labels are wrong.
It's the corrigendum.
I've lost count of how many corrigendums since the 18th came out.
The corrigendum.
Yeah, we should have a corrigendum for a corrigendum. So there's the label. We all know that. It's basic bread and butter stuff. However, they've rewritten the reg. An instruction notice of such durable material, so maybe someone's learning, as to likely to remain easily legible throughout the life of the installation, there's an asset management phrase, shall be fixed in a prominent position at or near the origin of every installation. In theory, this is a labeling sheet you could put in a switch room, maybe if it's commercial industrial. The notice shall be inscribed in indelible characters. They've removed not smaller than those illustrated here and shall read as follows. Now, I've moved the label to the next slide for a reason. Once you see the picture of it, you'll understand. It then has this bit at the bottom that says the requirements of this regulation need not be applied for domestic, household, premises, or similar installations where the fixing of the notice is not reasonably practicable, time and cost. For example, where there is insufficient room. That's not reasonably practical, is it really? I don't know. Or at the location of the notice is deemed unlikely to be beneficial. So basically stop labelling, and maybe there's a reason behind that. And an electrical installation certificate complete with guidance and instruction for recipients, as detailed in Appendix 6, has been issued to the person ordering the work. I don't know about you guys, but I sit at home every night reading electrical installation certificates because that's just how I roll.
I think the onus here is what they do want to do is try to get us to go a bit like they say in Guidance Notes 3, where there's a instruction manual. They want us to go down the avenue of providing to the client literature with an installation, with design criteria, drawings, and also warning information. Now, if we were doing that already, this would be easy to do. But the fact very few of us are actually doing that, there's some other work needed to instruct electricians to compose and create manuals for homeowners.
I don't think there is, and a manual for a homeowner wouldn't be a bad idea. But I do think there is some merit in having a labeling or a notifications form or template that's specific for an installation you can screw and fix onto the wall that has all that labeling near to the board. Maybe that's the way out. Maybe we could put traflight sheets or something up underneath staircases next to the boards that are indelible and give the information. Who knows?
Is there an aesthetics consideration here as well?
Yeah, here we go. So this is the label. So it's the depth of the square edge, everybody. It's not in black and white, by the way. I'm in screenshotting that really crappy website. It inverts. So yeah, what can you do? The installation of part of this is protected by a device which automatically switches off as supply of the fault develops. Test 6 monthly. Now, I completely disagree with this, and anyone who's commenting on this, it needs to just say test at a frequency recommended by manufacturer. Fusebox require monthly. ABB require 12 monthly. Or just put test periodically. Something, but don't, or leave a space for you to write in the time.
Yeah. It should just be as required by the manufacturer, and then maybe say in the absence of information 6 months or something like that.
Yeah,
we must put the manufacturer requirement ahead of that.
So we know most people don't read the labels. We still have a duty of care with that due diligence to put labels in where required. And also the next spark hopefully will thank you for labeling up something in an effective and efficient manner, especially if you're ferruling up and doing all the good stuff. It means someone's taking...
Terry says, how many homeowners actually test their RCDs? Let me know when you find one.
I would say none, basically. And but the problem with this thing now about you don't have to put labels on whatever, it'll put it in some kind of document, is that for domestic particularly, you're going to get the situation where we can't be bothered to put labels on it, so we're not going to bother. And then do they give the actual documents to customer? And even if they do, they go straight in the bin and no one ever looks at them again. So yeah, this could end up being just a not bother thing, certainly for domestic.
So the reason this is in here is, as you can tell, there is now a new appendix for labeling in the regulations and signage, etc. And what this has is a nice little key. It has a minimum size of font now. And yeah, so it's actually got a little bit more information and guidance, which we can challenge to make sure. I think, assuming they just want common sizing now, and evidently they're trying to overcompensate for their error of the last time.
Yeah, the size, I think it's a good idea to put the sizing in, as in specifying it's so many, whatever, points or millimeters or whatever, because previously it was just the size it's printed in this book. And the other problem with that is that, of course, there's all this stuff going to electronic versions of everything. Who knows what size it is, because whatever you're doing it on, obviously it isn't a particular print anymore. It's just a electronic thing on the screen. So at least we've got an actual defined size now. So
Richard Harrison's asked us, to be honest, do we test our own? No, I don't go out my way to test them. But I have, if I'm ever near my board and the missus isn't in and there's not much switched on, I will.
Eddie's asked that question as well. How many electricians test their RCDs?
We're our worst enemy. Let's be honest about it. In your own home, you're your own worst enemy. Yeah, my last rewire of my last house took me years. I had a mate come around and kick me up the backside to get it finished. It's always the way you're always working.
I regularly test one of them because my wife keeps tripping it. There's something going on in my kitchen in the oven.
Okay. Yeah,
that gets readily checked. That one works.
Okay, that one does work. Yeah, evidently.
Neil
Anyway, moving on.
There.
Moving on. Let's not get bogged down.
Hang on. John was about to say something.
Yeah, there was an interesting comment there from Neil Bridgman. He's put, in 2020, there's no reason why a small demo video could not be handed over with a finished installation or works. So.
I wouldn't want Neil Bridgman doing a demo video for me. That would just give me nightmares. To be honest with you, you can imagine that big old gorilla. Oof. Oh, that would be scary stuff. Oh, yeah. No, that would be interesting. All right, Neil, I challenge you. Do me a handover video. No,
good point, though. There's no reason why we couldn't try to more effectively give information to clients.
Yeah.
You know, the written word, especially labels in places where no one looks, is past us.
A QR code with a short video on how to test. Yeah, maybe. Listen, you've only got to go on YouTube. There's millions of videos now of how to wire everything. Right, okay, let's move on because there's lots to do. We've got hundreds of slides to go through.
Yeah, we do
tonight,
need to
guys.
move on, actually.
Right, sorry, John, apologies. 51412.1. So, other interesting label change, very minor. It says an instruction notice, this existing regulation, durable material like to be remain easily legible throughout the life shall be fixed prominent position. We know that is the periodic label. It's now changed. An instruction notice, durable material likely to be remain legible throughout the life of the installation shall be fixed in a prominent position at or near the origin of each installation upon completion of the work carried out in accordance with Chapter 6465 and breathe. The notice shall be inscribed with indelible characters, and they've deleted not small those illustrated here, and shall read as follows. The pictures on the next slide. It then adds again the same similar note. The requirements of this regulation need not be applied for domestic. So we've now lost the RCD test label. Potentially, we've lost the periodic inspection label. The fixing notice is not reasonably practicable. I think it's one I'm going to ignore. But yeah, it's down to the individual electrician. I get the reason behind this.
Yeah, I mean, I get it. I mean, if you think about it, if you run a business and you've got all your OEMs and your operational procedures, you don't need labels on things. If anything, you might need labels to remind instructed workers to check items of equipment, like posters around the workplace, to maintain that good culture. But for a business to actually have all the labeling on their panels, not really necessary if they've got the literature recorded that they can then hand to the next operative. And in the home, people aren't going to follow these instructions. So
Richard
in
Harrison made a very good point. Is this saying stickers are not now acceptable as they don't last the entirety of the install?
Well, one of them did say for the life of the installation, didn't it? Earlier
very
on.
Good point. How do we define that?
I think it depends on what the sticker's made of, because if you got, say, paper, that's not particularly durable. But if you get, say, vinyl ones, they last for like 10 years plus. So
yeah,
it all depends on what they're made of, I think.
But also, more importantly, is it ones that people can't rip off as well?
I just like that in I just like that 514.9.1.
Yeah.
Used to read a legible diagram, chart or table. Now just reads a diagram, chart or table. They've taken away the word legible.
It's because we just used a magic pen to write whatever.
I mean, it seems like a job.
Bad. Right, moving on, guys. There's lots to go through. Just a quick one on this, because I messed this one up yesterday, so I apologize and I hold my hands up. This is the current regulation for unwanted tripping. So this is the split board debate, okay? We know in the last regulations, this was introduced, unwanted tripping. Residual current devices shall be selected and erected to limit the risk of unwanted tripping. Following considerations: subdivision of circuits with individual RCDs. RCDs should be selected and the circuit subdivided in a way that any leakage likely to occur, normal operation of the connected load, will not cause unwanted tripping. So not fault current, just normal operation. In the order to avoid unwanted tripping by protective conductor currents and or earth leakage currents, the accumulation of such currents, the RCD should not be more than 30% of the rated residual operating current. So for a 30 milliamp, it was no more than 9 milliamps basically per circuit, which everyone went, where's the guidance? Where's the information? Where is it? Where's the leakage information? It caused chaos and it kind of, it just kept people away from going down the RCBO route. It then says, no, this will allow better selection of RCD due to nature of load. RCDs may operate at the value of residual current in excess of 50%. So you can use time delayed, you have to do coordination, selectivity, etc., and coordinate them with surge protection devices as well. So that's the existing reg. In the new bit, and I've just kept it in white so that I don't go blind, they have added an additional part in, and this is what we kind of missed yesterday. So you can still have all of the existing criteria, but there's an additional line that says the use of Rcbos for individual final circuits in domestic installations. And we will tell you why when we get into the testing part, because it's fairly evident that given the fact that yesterday we agreed that they'd removed anything up to 10 milliamp needed any special measures. The dual earthing on the back of sockets is now gone. It's fairly evident they're not worried about anything up to 10 milliamp.
Yeah, the high integrity earthing requirement for two
connections is gone, and you can see it's now just pushing people down that RCBO line. Is this well worded? No. Can it be better? Yes. Do we need to tell them our views? This is why this is we're doing this so that you guys can understand it. For anyone who is a learner or on that journey, just a quick reminder, different types of RCDs. When we say types, we don't mean MCBs. The type AC for general resistive loads. Type A provides up to 6 milliamp of DC protection, which is really not much. Type F is up to 10 milliamp with protection against high frequency loads. Type B is all types of DC, whether it be constant, chopped, inverted, etc., rectified, plus high frequency loads. When you go type F and B, it gets very expensive. As I said yesterday, there was a guy who had a coffee machine and dedicated circuit, lots of money. Moving on very quickly, again, I made this error yesterday, apologies. For general purposes only type A, regulation 531.3.3, note 3, for general purposes only type A RCDs may be used. So you can see now we are moving away from the AC type. It then says type AC RCDs shall only be used to serve fixed equipment where not portable, where it is known that the load contains no DC components. See note 4. Now that error is still in there. It's my fault because it was note 4 when I looked at it and then it changed. Note 2. Examples of fixed equipment containing no DC components may include, but not be limited to, electric heating appliances, resistive loads, and or simple filament lighting, which my dad still has, but does not include electronic transformers or dimmer. So finally, we got a bit more clearer guidance, really. AC is dying. It's a dying thing in this country. There are still places where it exists. It's on its way out. And then note 3 is for guidance on the correct use of RCDs. See PD IEC TR 62305, which is that standard there, which talks about leakage. It gives you a formula to work it out, which should be in the regs, and it's not. So shame on the people in the regs. And that's the table, and I've just recreated it above. And it gives some advice on generic values. But we've since discovered that Schneider have recently produced a good guide to RCDs with lots of values. But John, we know there are even more. They're hidden behind a £24,000 paywall from the Broken Standards Institute.
Yeah, the problem with that is that there's a whole set of standards, and there's like about 108 of them or something. And each one deals with a very specific type of appliance. So there might be one for, say, coffee makers and one for sort of washing machines and this sort of thing. And there's a line in each one that tells you what the leakage for that particular type of appliance is.
Yep.
So to get all of them, you'd have to literally spend that, 28,000 quid or whatever it was, get all the standards and then look in them each one, and on that single line, oh yes, that's 6 milliamps for such and such and 3 milliamps for this and all of that.
Is that a maximum permitted leakage allowance for the standard? Is that what those are?
Yeah, it's a maximum permitted, and then some are things like sort of so many milliamps per kilowatt of connected load, and some don't even have.
Once it goes over a value. We looked at this the other day, John, didn't we? And electric cookers, they were a maximum of 10 milliamp, which straight away warrants dedicated circuit.
Yeah.
So, you know, they're electronic, they're energy efficient now. So we need to accept that the definitely the split load RCD board is coming, which in theory for a lot of electricians should be a stimulator. It's going to be interesting to see how people are coding this, but I agree this could be worded better. It should be worded better, and there should be guidance. And I'm going to make the comment when I do my commenting. There should be an appendix that gives all of the leakage, so that electricians can select and erect and ask questions about the use, so that they can take all reasonable steps to design accordingly.
Yeah, I mean, we don't need the whole lot of the standards
No.
because most of it is about how appliances are made and what criteria they're designed to. So it is literally just a line in each one, which needs to go into a table and be stuck in the back. So
yeah, it's a bit of a coding headache. Neil's right. Richard Harrison, bang on. When the 18th came out, I actually used this slide when the 18th come out, and it did make you wonder when you look at other appliances or mobiles or printers and PCs, because you're limiting the amount of equipment you can have very quickly. So the output was always going to be bigger boards.
It's one of the biggest questions I had myself that I'd asked myself when I delivered the course. When I say, right, we now can't go over 30%, that equates to 9 milliamp. They'll go, well, how much? And that's the problem. You couldn't quantify it because all that data is behind these.
If someone can put in the chat the link to the Schneider document, it's a very good guide to Varsities, very up to date, lots of good information. It's got the leakage stuff in the back. Great bit of data to go from. Very quickly now, the last bit in chapter 5, 534417, there is a requirement for a label of a surge protection device, but it's the presence of surge protection devices installed downstream of a distribution board, potentially type 2s or type 3s, i.e. in a socket outlet, shall be permanently indicated by a label at or near the distribution board. That has now been rewritten. It now says the presence of surge protection devices in an installation shall be indicated by a label at or near the distribution board. The label shall also include instructions for checking the status indicator of the SPD. The requirements of this regulation need not be applied for domestic household premises or simple installations where the fixing the label is not reasonably practicable. So it's the exact same thing as in the last one. So it's, you shall put a label in, but if you can't practically fit it in, you don't need to. These regs are getting weirder. Do it, but you don't have to. Do we have to document and justify all these decisions? Be good to have a bit more information. So yeah, surge protection label, a bit more clarity. I like the first paragraph. To be honest with you, that is common sense through and through. To be honest with you, much clearer. Not against that reg.
Cheers, Andrew. Thank you for that.
What's that? Oh, Andrew, thank you. Andrew, hopefully, is he related to Peter? Great surname. Right, so part 6, inspection and testing. So a couple of reg changes, just very minor formatting. 64331, the insulation resistance shall be measured between live conductors and between live conductors, protective conductor. It was poorly worded. It's now formatted like that. The insulation resistance shall be measured between live conductors and protective conductor connected to the earthing arrangement. During this measurement, line and neutral conductors may be connected together. So they've just formatted it. No real change there whatsoever, just a formatting issue. 643.3.3, insulation resistance. It used to state where the circuit includes electronic devices which are likely to influence the results or be damaged, only a measurement between the live conductors connected together and the earthing arrangement shall be made. Now states where equipment is likely to influence the verification test or be damaged, the test shall be applied prior to the connection of such equipment in accordance with table 64. So yeah, basically try not to blow up connected equipment. Following connection of the equipment, a test at 250 volt DC shall be applied between live conductors and the protective conductors connected to the earthing arrangement. The insulation resistance shall have a value of at least 1 mega ohm. They have then deleted the note which says additional precautions such as disconnection may be necessary to avoid damage. They've just basically reworded it. One minor change, earth loop impedance and prospective fault current, regulation 64373. There are 2 new notes. The validity of test readings taken with fault loop impedance test instruments may be adversely affected by power converting equipment, such as inverters. Yeah, no poo Sherlock. Anyone who's tested UPSs knows that when you do an earth loop, it will affect it. It's an inverter. Note 2, further information on measurement of earth loop impedances can be found in Appendix 3. There is then this section here where protective measures are used. That's existing information, so there's no change there. They then added a note. Further information on measurement of earth loop impedance can be found. Why have I repeated that? Sorry, there's another mistake. Apologies. That's the exact same as note 2. I don't know why that's like that. That's my bad. But yeah, so it's just a couple of additional notes, basically giving you a warning about affecting of loops. But the key thing is and prospective fault current.
Yeah.
That's now telling us to test for fault current values. Be interesting to see what everybody is thinking about that. Same bloke who's been doing Boris's lockdown rules on JPEL now. Yes, I wish it was. Okay, so there's a lot to go through, so I'm going to go through this a bit of a pace.
Just
Sorry.
So Jonathan asked about selectivity of types of RCDs are still not addressed in this. Other than the coordination the way it was before, there's nothing new addressed about coordination of different types or selectivity of different types. But there is in that Schneider document the different types A, C, V, and all that. So there's nothing specifically on the rigs in that. Sorry.
They also need to harmonise all the different types as well, because you've got like the ASI version, and every manufacturer's got their own variants of types now. Which is a bit of a worry. So 634.8 additional protection, which is about the verification of the effectiveness of the testing of RCDs. Nothing's changed except for the note, which is deleted. The note has been deleted when you say effectiveness is deemed to be verified when 4.151 disconnects within 40 milliseconds. So the 5 times test is gone. They've deleted it. That's probably Hager and that whole shenanigans with 250 milliamp 5 times and all the rest of it. Yeah. So the 5 times test is gone. I have a view on it. I'm still going to do it. I work from the regs, not to them. So what we'll do is we'll show you some model forms. Okay. So this took ages screen grabbing this. So hopefully you can all read it. This took hours getting this. Right. Electrical installation certificate. These are the changes. They are removed in red. So details of clients, everything stays the same pretty much except for in design. They have removed where it says having exercised reasonable skill and care when carrying out the design, and additionally where this certificate applies to an additional alteration, the safety of the existing installation is not impaired. Okay, so what they've done is remove the line that says the designer's work won't impair the safety of the installation. Yeah,
really to the point of that. It's tinkering around with stuff.
Let's just spray Teflon.
Does that mean you don't have to declare that anymore?
You know what this is probably about? This is a designer on a major project went absolutely tits up. I'm not going to mention one, but it's underground and it's very late. And they've probably realised the design was fundamentally flawed, and these certificates were used as an argument because of the designer's duty to ensure that their design doesn't give rise to danger.
Mm-hmm.
Let's get it changed. I don't agree with that.
Richard, the times 5 was always adopted because of the requirement of additional protection would say that 40 milliseconds test, and the way to achieve that would be at 5i delta n. That moved in the 18th edition from 415.1.1 into part 6, and it's now just vanished. When that did move, we had this issue with, was it Hager?
Yep.
They had a device that tested at a different current level. The question really is, how do we determine additional protection?
Yeah.
You know, what is protection now?
That additional current level was a crock because it was one reference in one table in a 180-page standard with no other reference. And in fairness, they did actually modify their devices. It took a while to bring them in line, which, manufacturers influencing standards. Hey, it always impacts the spark.
Everything's going to be updated. If this stays like this, all the guidance notes and all those publications are going to have to change as well.
Yeah, new books. The last bit, details of departure from 7671. The permitted exemptions, the risk assessment is gone, guys.
Sorry, hang on. Yeah, Richard, I agree. As Paul said, work from the regs. If the RCD is there for additional protection, the times 1 would not be substantial. You need instantaneous disconnection. So I would just install a higher, I'd test at a higher current to achieve instantaneous disconnection, whether the regs said so or not.
Yeah, I mean, all the testing equipment is still going to do it, so it's not as if it's some problem in doing it. It's just it's not in the book anymore.
I have massive issue with the risk assessment being deleted, and I'll be challenging that because there are places, especially on railways, where you do not put RCDs, operational impact, revenue impact. No, absolutely stupid. In domestic, fine, but they needed to then say in domestic, no risk assessment. Non-domestic, give us some float. So I'm going to make a suggestion that they reinstate that. Right.
Yeah, it really struggles to. It really struggles on their ability to. For them to do that, there must be really no trust in the ability for a risk assessment to be done competently these days, or something. Why is that? What justification is there for that risk assessment to be removed? Otherwise,
sales boost.
It can't just be that. We can't say we want to increase sales, so let's take away the ability to assess risk. Surely,
competence of the industry.
Oh,
I don't know.
I think you're right on one of those 2 answers, and I hate both of them.
Yeah, I know. So do I.
The problem with risk assessments is that who's writing it, and are they competent to be writing risk assessments in the first place?
Yeah.
Eddie Clements has said, would you put life support machine on RCD? No, absolutely not. And people do have dialysis machines and stuff at home nowadays, and medical systems at home. So, no, this is not it's not a practical. There always must be, if you are the selector and erector and you're the designer and you're taking all due care and attention to work from the regs and select and erect accordingly, you should be allowed to put in AFDD where you need to, RCD where you need to, and non-RCD where you need to for particular use, and then give said instructions to the user for safe operation. We're having all these decisions taken out of our hands, which is wrong, because it makes it easier for a certain part of our industry to just work to rule to thumb.
Yeah, Cam's saying, I'm struggling to find a reason why there's no 5 times test anymore. Don't worry, mate, we're the same, but this has just been announced, so you have the opportunity to comment now, but we don't leave it like this. We will go fishing. We will find out, won't we? We'll go fishing for the reason why, and we'll figure it out.
Yeah, well, we know we're going to be going fishing because, if it's fair to say, not being an awkward bugger, I already have a few British standards that I'm going to be reading, which deal with this. I'll be rereading them. Anyway, moving on. Bottom of the certificate, no real changes on the signatures, the wording of it, so that's fine. Particulars of signatory, one key change on the signatory page where it says external earth loop impedance. They've deleted external and now put earth fault loop impedance. Really? Seriously? Come on, guys. So we're not testing ZEs anymore now?
It's a supply parameter.
But hang on.
So
no, it says ZE. It says ZE, which means
ZE
external.
symbol.
So what genius? How much money did these people get paid to sit in that meeting and come up with that one?
Is this standardized? Is that the problem? Is that why that's happened? Is that happening in 60364?
We should check that.
Might be.
We should check it. Let's 60364-6. We'll have a look. We'll have a look and we'll let you know. Right, here's okay. So on the next part of the certificate, the bottom part, whole new section. So they've deleted 2 extraneous conductive parts. They then put if RCD main switch, they want the type now, which is a great insert. But this new one, schedule of inspections, the outcome positive on 1, 2, 3. So condition of consumer's intake, parallel switch to alternative source supply, methods of protection, basic protection. This is a whole new section, which is now in here, and this is the electrical installation certificate. So this is kind of a throwback. Do you remember when they used to have that little tick list? You had to comply. This is kind of a modern version of it, I suppose. At the bottom, they've then deleted the attached schedules as part of this document. They've then changed it to this certificate is valid only when schedule of test results are attached.
Okay.
So there you go.
Just
now
rewording on that one.
Model form EICR. So the EICR, they have destroyed the tradition of my industry. If anybody remembers yesterday, dwellings is a new term. You now no longer tick domestic, it's dwellings. Really? Domestic, commercial, industrial, 3 things that roll off 3 parts of sectors of our industry, and now it's dwellings. You're not a domestic electrician, you're a dwelling electrician.
Okay, let's give us 30 seconds for everyone to decide. Is there a significant difference between what is a domestic environment and what could be typically considered as a dwelling environment to us? So a couple of notes, a couple of yes. So
dwelling electrician on the side of the
that sounds like somebody who sits and goes, "Hey, precious."
Okay, so Jay's come up with the HMO. This is what I'm wondering. I'm wondering if maybe a building like a nurse home or something like that might be considered as a dwelling type of environment, but not a domestic.
Jonathan has put a brilliant
NIC
dwelling installer. Change all the labels on the van. It's just going to look so stupid.
Yeah.
Oh dear, they didn't think that one out.
Yeah. Majority is no. There's a few yes. Let's move on.
Yeah, move on.
Yeah.
Last bit is just on the front bit. Section F, recommendations. Subject to necessary remedial action being taken, I or we recommend the installation is further inspected by and a date. But then it now adds for the following reasons, which is a great addition. Because rather than just using that crappy table in GN3, which is really only for designers on new installations, you've now got to tell them why. And you can't just put because it's shit, because the next spark will see that.
And I think
Right.
as part of this whole thing about 10 years being the default needs to go away, because 10 years for a lot of installations is way too long.
Yeah, it is. Yeah,
Way too
definitely.
long.
Especially with all the smart stuff and the alterations people are making to their homes. Smart homes are becoming more affordable. People want better homes and bigger homes, etc., etc. But yeah, NIC dwelling installer. That's a fantastic one. Thank you, John. That's cheered me up a bit. Right, let's go to section I now. Supply characteristics. Again, they've deleted external. Well, that's and to extraneous parts. At the bottom, they've got if RCD main switch, RCD type. That's great. Nothing really changes on the observations, which is fine.
No change in coding strategies.
No changes in the coding. C1, C2, C3, FI.
Okay.
Please watch the videos if you want more info on that. We need to change the domestic EICR1 to dwelling now. We should have called it that. If only we knew, but there you go. Model form, minor works.
Minor work.
There we go. I like this. This is one of my favorite forms because this has grown over the years. So they've removed IET wiring regs, so it's now 7671. Clever. Details of any departures, removed if any. So, okay, that's good.
Yep.
As amended to, yeah, put the latest revision in. Risk assessment attached. No, that needs to stay in. Other than that, it remains the same. Supply and adequacy of earthing. That's fantastic. Circuit details. Oh, some new bits here. RCD, BSEN, type, rating, and residual current rating. AFDD. If you remember yesterday, we now know that AFDDs are a shall. Although there's a list of exemptions, which includes lighting and showers, like we predicted last year.
Are they not always 62606?
AFDD is, the product standard is 62606, and there has been a amendment to it last year. But they still don't have a three-phase version, and they only work up to a light commercial. So domestic and light commercial, you wouldn't put them in the railway. They wouldn't work. They don't have the pollution category for it. Plus, they're limited between 2.5 amp and I think it's 32 or 40 amps they go up to.
Yeah.
But yeah, it's 60.
40, I think. No, 32.
But maybe there is something coming down the line. I don't know. Maybe they just need to put it in there.
It's in their interest it's in their interest for these devices to work on all circuits possible.
Yes. So 62606 is the standard for AFDDs. Learn it like you know 61009 and 62898. Part 4, test results for the circuit or altered or extended. Test voltage is now required to be inserted. RCD operation is now looks like a tick box, which is interesting.
I don't like that.
AFDD, well, I suppose it's in there because the bit about the rated operating current is above now, so that's just been moved above.
Yeah, but if they're going to make these little changes, can't they do something also that's a bit more sensible, like maybe putting in a ramp test field or something?
Sensitivity of RCD would be a beautiful thing, wouldn't it? Maybe the guys listening can comment if you can get the broken standards website to work. Anyway, AFDD satisfactory test button. Note, not all AFDDs have a test button, and as Mr. Ward rightly said earlier on while we were chewing the fat, a lot of the AFDDs we're purchasing are combined with Rcbos, but there are other ones available as modules that bolt in and connect in like a shunt and operate. So yeah, it's a valid point, although I wouldn't buy one without a test button, to be perfectly frank.
Yeah.
Declaration, no change other than they've just removed IET wiring regulations.
Can you go back a slide?
Sorry, that one?
Paul's asked, why have a tick box for the RCD if there's a tick box for the button below? So he's got RCD operation with a tick box and satisfactory test button operation box. So the RCD operation box, the new one, is that a tick to confirm that it's achieved the required disconnection to test?
It's a box. It's a tick box, isn't it? But you are right as well, because the RCD operation on a lot of the devices, like the Electrium one, when you push that RCD test button, it will also act as an AFDD checker as well and get the electronics to do their bit as well. So
just seems like it seems a bit redundant to have two boxes.
You don't have two buttons on some devices. That's the problem. You do on some.
Yeah, but no, the point is there's satisfactory test button under RCD operation. Is that the test button of the RCD?
Yes.
And so the RCD operation box, that's a tick to confirm the test has been satisfactory.
I would assume so, yeah.
Okay.
It's the only information I'm going on. RCD operation tick. Could we do with more information? There's plenty of space in that box, damn right.
We could do with not taking information out of the form.
Mm-hmm. I think there's more that needs to go into that, to be perfectly frank, but I'll take my hat off to them. They've added some more bits in. The minor works to me is an absolutely critical form.
Andy,
such an
Andy and Sean in the chat have mentioned there's no mention of PFC here. I agree. PFC at the end of the final circuit.
Oh, that's a good point.
Short
And
circuit currents, something we've been trying.
there's an additional requirement there, isn't there? And they've not missed it in their forms. So maybe we'll cover that in a second. So let's have a quick look. Hang on, let's keep going on. Part 5 declaration, we know there's just removal of wiring regs. Now let's go into the big one, the schedule. So I'm going to apologize now because the website is so bad. So bad. This is as good as I could get a screenshot of it. And trust me, it was a nightmare just finding this. So DB reference number location. Now, ZDB is a new term. We didn't mention that yesterday, but it is a new term in part 2. Correct polarity confirmed at DB. You have to wonder sometimes some of these checks, but that's all fine. Tested by name, signature. Now, if you look at the circuit details, they've added a whole new section in here called RCD. So now, which is a bit weird, we have then BSEN here. We have type, so A, B, F. We have the I delta N rating and the rating in current. We then have conductor details, ring final continuity of conductors, insulation resistance test voltage, and now we have the change on polarity is just a note that says please insert a tick or a cross. Now, who would cross that I haven't got polarity and walk away? Are we that bad as an industry now that we'd cross it and or
don't forget some of us now do
test it?
Some of us now do third-party nonsense, don't we?
Mother of God. Wow. Yeah, but interesting. So there's ZS, polarity, RCD, AFDD, remarks, but no, there is nowhere to record any fault current other than at the DB.
Yeah, so you still cannot record the end of the final circuit short circuit
Nope.
current.
Yet the wording of that regulation we just went to infers that you have to record it because that's an addition to that title. But yeah. Okay, that's enough of me. 1 to 6. Hey, what an idiot. Right.
All right, 7. This is the kind of thing that I've had a little look-see at. It's actually not that interesting, is it? All right. So 701, 702, and 703, swimming pools, bathrooms, saunas, etc. They've had a minor tweak, which is sources for self. It just means if you have a source for self in the zones, this particular regulation now says a source of self to 414.3.4 shall not be used. And this is the little snapshot from 414.3.4, which just refers to electronics being used to achieve protection. So it says certain electronic devices comply with appropriate standards where provisions have been taken such that even in the case of an internal fault, the voltage of the outcoming terminals cannot exceed the value specified in 414.1.1. That's just self and PELV. Higher voltages at the outcoming terminals are, however, allowed in the case of contact with a live part or in the event of a fault between live parts and exposed conductive parts. This, I think, is why they're going, oh, we don't like that when we have the presence of water. So they don't allow this exception as a source of self because I think of that second half there where this method would allow a higher voltage to occur. So this one mention of a source for self has been excluded from those 3 special locations.
Just going on to, there's a quick note from Paul Brewerton. Did he blink and miss the schedule of inspections? No, that one is a bit of a nightmare. It looks like there's no changes from what we could see, but it would just take too long, and we were trying to go through the treacle basically, so it was taking the key bits within the time we had. Otherwise, this genuinely would be like a 4 or 5 night.
Yeah, as far as I can see, there's no actual changes, although they've moved some of the bits about in where they appear in the order of stuff, but it looks like it's just the same. But we'll look at that at another time and see if there's anything that's obvious there. So.
Indeed. What I do is just on that one, Dave, when I see that slide, I immediately think trust but verify. Because a lot of installers are going to be relying on manufacturers to ensure that their equipment is compliant, and if it fails safe. A lot of it's car salesman time, isn't it? You can trust them, but you still need them to verify that their equipment is fully compliant. We know that there's more onus on the installer to validate and verify the equipment is compliant.
And the thing is, you might buy equipment and it might say it's self, but we now need to obviously be aware of how it achieves self. And if it achieves self in this way, it wouldn't be suitable.
And there's those little transformer things that say self-equivalent on them and other nonsense, which you have to wonder what earth's inside those things.
This next one's just a new little regulation that's squeezed into 704. Overvoltage protection required due to switching operations on construction sites. Cranes, lifts, cement mixers, and similar items liable to produce a switching overvoltage. So even temporary systems on construction sites, we've got to consider SPDs, things like that. So that's nice. I like to see that because that takes my argument into things like 7909 as well with switching overvoltages.
And 7375 construction sites, if they ever update that.
Yeah.
Interesting. Yeah, no, okay. Interesting stuff. So moving on.
706, conducting location with restricted movement. They've just added a bit of supplementary bonding. So you got here 706.415.2, which is a supplementary bonding form of additional protection. It basically means we're using Earth for functional purposes a lot lately. And if we're in this location and the earthing around us, or there's any earthing around us that is used for functional purposes, we need to cross-connect and supplementary bond the crap out of it.
Okay.
Yeah. And you may see this symbol more commonly now because this is being pushed a lot lately due to the new 5th edition of the Code of Practice. It's just a symbol for functional earthing. 711 exhibition shows and stands. This is, right, first part is fairly simple. It's just an extra bit of protection for Rcds. Mentions that all final circuits not exceeding 32 amps that supply socket outlets, all final circuits for lighting, and all final circuits supplying hand equipment rated no higher than 32 amp will be on an RCD, self or PELV, or electrical separation. The key thing here, this is very similar to a lot of other special locations like agricultural, horticultural, where it says, right, well, those types of final circuits where we can have handheld equipment or low current lighting, they need to have RCDs. It does say the protective measure of electrical separation for the supply of more than one item of current use equipment shall not be used. So if we use electrical separation, it's got to be the electrical separation for one item only, instead of that specialist situation where electrical separation can actually supply more than one item. I've highlighted item of in yellow there because that's actually not in the text. It just reads more than one current use equipment. So that's a comment I've got to make after this. There's a couple of words I think missing from that regulation.
Not surprised.
Yeah.
Okay.
This is an old reg. So the TN system, it basically would say we don't want to use PME. PME is not suitable for exhibition shows and stands unless it's continuously supervised by skilled or instructed persons and the suitability and effectiveness have been ascertained and suitable. That's gone. We've now got this next one. Oh,
sorry.
Yeah. I could read all this out, but well, I'll read a bit of it out. So we've got PME earthing facility not to be used, the means of earthing, except where one of the following. We've got protection against electric shock provided by a device which disconnects the unit from live conductors of the supply and for protective earth in accordance with 543.3.3.101. In 5 seconds, in the event of voltage between the circuit protective conductor and earth exceeds 70 volts RMS due to an open circuit fault in the PEN conductor on the low voltage network. This device is not operated if the voltage exceeds 70 volts for less than 4 seconds. Now, without me getting through the rest of this, if you guys are familiar with 722 and the recent amendments to 722, there should be a lot of familiarity with this, because this is basically a copy and paste approach that they've taken with 722, where we have this issue of installations that can go outside and the use of PME.
It's fairly evident, Dave, that the PME risk issue is becoming a more. We've been talking about it in recent DNO webinars where the PME, which again, the PME earthing facility is what's on the cable, but the TNCS system itself, the use of that within an installation, there is evidently becoming more CNE losses, whatever you want to call it. There are becoming more broken PEN conductors, which is causing this. So the requirements of that almost OPEN technology is now innovating its way through the special occasions. And I have said this to the chairman of JPEL, this needs to be in the main body of the wiring regulations. If we've had nearly 1,000 people injured a year from broken PENs, then we need to be installing this and we need to be taking measures. The trouble is the industry doesn't know what measures to take because it would involve TTing potentially or isolating transformers and getting very, very complex. And John's about to do that in a minute. So, right.
Yeah, the bottom of that just said that if you couldn't achieve the one above, you need a device that achieves the same thing. Again, much like in 722. but you may have a special device that achieves the same level of protection.
Yeah, we need to do something separate just covering this. I think when we do our DNO webinar, the next one, we'll cover this because we need to.
Let me look at the comments before we move on to Solid.
Oh, sorry. Apologies.
DNO. Dave says, surely DNO should be installing these.
The DNO should be fined for every broken pen, £1 million. There you go. I've said it. They're supposed to be maintaining the network, and if we have a potential danger because of value engineering in the 70s, they should be paying for it, but they're not. They're Tefloning onto the homeowner and the installer, and it's not fair.
And Andy says, any clarity on whether 7909 applies, and what about TNS stop being TNS? Well, 7909 doesn't. There's not a clear line as to what is 711 and what is 7909. There's some good interpretation about it. I think probably one of James E's books probably put it best, where he tried to explain the difference between an event and just a work exhibition. The way I think about it is 7909 has to be read in line with 7671. It says right at the beginning of 7909 that this must achieve full compliance and coordination with the fundamental principles of 7671. And the fundamental principles of 7671 will push through to part 7 to supplement the rest. So in my view, I'll comply with BS7671, and then if necessary, I'll then add to 7909.
Yeah. Regulation 11013, part 9, temporary events. But yeah, there's more that needs to be done. So our second DNO one, we'll hit this head on and go into it in some detail.
Yeah. Okay. PV. Okay. We've talked about Prosumer yesterday. Briefly. We'll talk about it a lot more soon. But because obviously with Prosumer, we're going to be changing some of the use of or purpose of PV, they've had to rewrite the scope. Because before when it was introduced, it was mainly for the feed-in purpose. So it's had a rewrite of scope. It just says it now applies to installations of PV generators intended to supply all or part of an installation and feeding of electricity into the public grid or local distribution. Okay. In this section, equipment of a PV generator, like any other item of equipment, is dealt with only so far as its selection and application of the installation is concerned. The installation of a PV generator starts from the module or a set of modules. So I don't know if you guys are familiar, we connect the cells, form the modules connect into a string in series, then we connect the strings in parallel to create the array. I don't know. Can you remember that from your solar training, Paul? Can you remember that?
I can, yeah. I've played with many a string.
It's all about the magic of creating that right value of voltage and then creating the current and then creating the whole thing. PV module manufacturers, up to the user installation or the utility supply point. Requirements of this section apply to one of the following. All right, next slide there, mate. So the scope of this applies to either using PV generators to supply an installation which is not connected to a system for distribution of electricity to the public, so not connected to feed the grid, maybe like an island mode or something. PV generators supplying an installation in parallel, so cross-connected with the grid as well, and generators for supply to installation as an alternative, so as a standby. So 3 different operation modes there, okay, all within the scope. So anything else that's new? This next slide. This actually I thought was quite funny. 712.4.2, protection against thermal effects. 4.2, chapter 42 is thermal effects. It's just got here 420.101, safety of a PV generator. Note, applicable national or local fire protection requirements apply. That's what it says. I didn't
think the reform order of BS999 covered solar PV, but
that's all it says under that one little regulation.
I think it's fairly evident why, because a lot of PV over the years, because PV's been around now good 20 years now. I remember doing my PV seating guild 15 years ago, and there have been a number of reported fires. We know we've got reports from Germany where there's been DC leakage from the panels. There's been connectors that have failed, and anyone who does PV will know this far better than me, but I think the technology is definitely getting now. It's matured after many errors.
Sorry, can you go to the previous slide?
Oh, sorry.
Just before this. Right. Andy says, what about small-scale wind generators? Where is there nothing on these? It's got in the note here of scope for PV that requires PV generators with batteries or other energy storage. They're under consideration. What's not happened here is we haven't actually got regulation on the storage of power from that renewable, which is also where that small scale wind generator would also come from.
Yep.
So that's not been brought into this.
But we know it's in 60364 part 8-2 and 3. So
it's
it's
there,
fairly
it's
evident
just not there yet.
it's going to be an Amendment 3.
Yeah. God, don't start talking about Amendment 3 yet.
Sorry.
Comment there about is 70 volts now deemed a safe touch? Well, the answer is no, and it's also yes, because it depends on where it is and what the circumstances are as to whether it's safe or not. So although there is 70 volt in quite a few bits, the other 55 thing is still there as well. So
yeah,
it depends on the circumstances.
I use 41162, which has the formula in it. So RA times ID should be greater or less than 50 volts. That's the one I've always gone to. For an AC LV general distribution system, I use 50 volts. I have issues at the moment because if you look at other standards, they do reference step voltages and touch voltages, and then infer compliance with the wiring regs is compliance with that standard, but they're not. They're fundamentally totally different polar opposites. But I think that comes down to standards getting their act together and having different views.
there has been a cross interpretation, I think, with regards to that. I also use the same formula when I do things like supplementary bonding. I always refer to 50 volts, so I can be aware of and quantify the voltage there. When they start throwing 70 volts, it does confuse the issue a bit.
Okay.
Let's try the next slide, Stu. Okay, next one.
On that one.
There we go. Right. So this is fire. We're still in 42. So a couple of things about fire. So it's got protection against the effects of insulation faults on the DC side in case of simple separation inside the inverter or on the AC side, so that we've got to consider protection of the DC side of the array. It's recommended that a fault be eliminated with the shortest practicable delay. So if we have faults, how is the DC side of an array protected right now if there's faults on that? Is it just controlled in the inverter? Is there other protection?
Well, no, there'll be some sort of in the more expensive panels, you'll get protection built into the panel to protect the output on the string, but there's no surge protection or anything like that. At the end of the day, these panels, the minute light hits them, they're generating.
So it goes on to say an installation monitoring device or an IMD is to be installed except where 7.12.421.1012 applies, which is just below. And this IMD is going to verify the installation status on the DC side throughout the life cycle. There's that life cycle term again, Paul.
Yeah, it's because they probably watched our webinar, didn't really understand anything about asset management.
The PV array. And this is something you have to make, it's an important decision to make at the point of design. You've got to consider the life cycle of the equipment. This is something we did cover in this asset management webinar. And IMDs are there to do that. They will constantly carry out tests, and they'll give you the first hint of installation degradation. The monitoring function may be provided by an inverter with integrated installation monitoring, also capable of detecting installation faults.
Most of the big ones do, the commercial industrial ones do.
Yeah, so they have IMDs within their inverters already?
They do, yeah. The ones that I've just installed have all got them built in, but I've still got DC surge protection installed.
Yes, so you kind of went ahead already with that one.
Well, I'd already read the document, so I went, yep, I'm just going to preempt this.
Okay, the alternative to the IMD is if there's functional bonding. Functional bonding. This is another term. Applied to live conductor inside the inverter on the DC side means to be provided to ensure the interruption of the fault current in a case of installation fault to earth in accordance with table 7.12.537. So that's
the functional bonding, because functional earthing was always if you break the earth, it stops, the equipment stops, it doesn't work. It needs it for the operation of the equipment, i.e. balance load, three-phase motor or something. What the frick is functional bonding? I don't even think that's in the terms.
I need to look into.
Part 2. We need to look into that. Maybe someone who knows can tell us. But yeah, we don't know everything, everybody. But this is a good debate regardless. We do know there's been lots of fires on solar systems. Yeah,
indeed. Okay, so that was protection against thermal effect. This is Overcurrent 4.3. This is a minor introduction. So we've got here, with regards to the nature of the circuit, because obviously you can have a variety of different array configurations. In a PV array, the number of strings above 2 strings in parallel protected devices shall be provided to protect each PV string where the following condition is met. So we have this little formula here, 1.35 times, and it's current. What do we think this is? The module maximum?
I looked this up earlier.
Yeah.
And it's actually the PV module maximum overcurrent protection rating determined by IEC 61730-2.
Okay, which is
just really sad.
on a page number.
So
good. So is that literally that comes with the module? Do you think?
Yeah, it also says there's a note that says this is often specified by module manufacturers as the maximum series fuse rating.
I'm familiar with that.
It's basically going to be what the manufacturer of the module actually states, and that's that particular value that goes in.
Okay, I just missed the old time of the knee curve. That was much easier to work out. Okay, so this is obviously about tolerance, full current tolerance of the array, but there's a number of different formulas, and there's pages of that, and so we concluded it's just currently Guff, and the reason we're going to call it Guff right now is because we haven't got the time to go through every single example that's in this. But
yeah, it's pretty much a full rewrite, isn't it?
Yeah, it's a rewrite, and this kind of gives me a headache with regards to training when I think about how train's going to adjust to this. But we probably will revisit this one section 712. There's a few things for us to kind of go on a learning journey here, and probably we'll do another webinar on it in a few weeks' time or something.
Daniel Casey has found the definition for functional bonding conductor as a
cool. What's he got?
Conductor provided for functional equipotential bonding, which is completely useless, really. But anyway, that's what it says.
It appears to be in relation to stuff that requires a ground reference to actually work, Sean says.
If you went to a football game and did this, you'd have the entire crowd singing, "You don't know what you're doing."
But that's what I love about this, right? Instead of like webinars and things on Facebook, these guys in this room are actually going off and finding answers for us.
Yeah, and it's worth saying thanks, everybody, actually. For
demonstrate, and this conversation may carry on later on. It's great because
Sean's gone mad finding some links. Come on, let's plow on because part 8's a big one.
All right. The another thing to add here is in 712, there's now a mention of SPDs. Now, Paul, you've actually experienced this before, haven't you? You've given yourself a little cheer there. Apparently, SPDs haven't been often installed on PV arrays. And
so I have just installed 5 solar PV arrays of various sizes across railway stations. And when I had the design out, we were currently in one of our Friday night marathons, which we never record. We were talking about the IEC standards, talking about DC protection. So I went away and read it, sat down with my solar contractor and reviewed the design and said, well, where's the protection on the DC side? How am I protecting my inverter? And they went, no, it's done inside. No, it wasn't. So we then went to the manufacturer of the inverter and they were like, yeah, no, you can have that separate. Great, can I have it? And they were like, well, it's not in the regs. Don't care, it will be. Put it in. Pleased to say every one of my railway stations has DC surge protection. Thank you very much.
Yeah. It makes total sense as well from the value of the equipment, because inverters are expensive bits of equipment, and obviously
of course they are.
You don't want to blow up, do you?
And also isolators as well. I have actual rotary isolators rather than these nasty plugs. And the reason I don't trust those plugs, I know the manufacturers say they're great, but I read a few articles about arc flashes in America where these plugs had failed over a period of time. They become brittle, and as they were disconnected, again, wrong working practices, but still remove the risk.
Yeah, and we had a similar discussion with Kirsty about the same thing with SPDs on electric vehicles, didn't we? Just sometimes overvoltage protection isn't applied when it always should be. Eddie's just put into the chat that he's just checked the Irish regs, which obviously are much closer to the European regs. The terminology reference to external loop impedance is earth fault loop impedance, and so yeah, it's probably a standardization.
Thank you, Eddie.
Just for
a bit of feedback. Maybe it's just us old school people just like our old ways of doing things. Yeah. But thanks for clarifying that. Right, eventually. 717.
717's mobile or transportable units. Again, you think about what we just covered with exhibition shows and stands, where we talked about the possibility of a PME supplying equipment that may be used outdoors. This is the same thing.
Dave?
Yeah.
A song comes to mind. There's something happening here. And what it is ain't exactly clear, because it's fairly evident that this PME issue is spreading through the regs.
It is, isn't it?
It's not going to go away. We need to be mindful of it.
So the approach here is, if a PME facility, it should not be used as a means of earthing unless it falls within the scope of this section, except where the following. It's located within or outdoors on an upper story or roof, a building or structure containing the installation which supplies the unit. So this is the temporary unit. Or we then have this regulation, which if we look at it, there's a mention there of 543.3.3, 101, 5 seconds, 70 volts for less than 4 seconds. It's the same thing. It's the same type of device, the same type of protection that we had back in 711, that we have in 722. So this device and this method of 70 volts for no more than 4 seconds, or it's got to turn off, is spreading.
Yeah, this is just another copy and paste effort, essentially, from what we've already seen, and it's just taking it out and sticking it in several other places. For
And that is literally what they're doing. They're just changing the word vehicle to equipment, and then equipment to unit. That's pretty much what they are doing. The method, the approach is the same.
Sorry, I'm just looking at a standard. There was guidance on the effects of current on human beings. 717.
You know, yeah, we were actually going to do something on this human beings thing, weren't we?
Yeah, it's complex.
Okay.
It's just more on the pen failure, isn't it?
Yeah, right. The 711 has an annex, as does 717, as does a few. I've just added the annex of 717. This is just guidance on this thing that we're discussing here. So this is an annex bit that's added to 717. It just says that it's describing a device that measures the voltage between the circuit protective conductor and the electric vehicle charging equipment and earth.
Yeah.
Okay. That is from 717, and it's saying electric vehicle charging equipment. So I don't know if they've just copied that from 722.
It's fairly evident, though, that, I mean, that Annex 711, I personally think that needs to be slotted somewhere into the main body of the regs, because take out electric vehicle, it should be the installation.
What they need to do is they need to go back to 4.1, and they need to go to TN systems in 4.1, and with TN systems, they need to have, if PME is installed and then you're outside, just have this protection as a standard. Then you haven't got to keep repeating it. Okay, but yeah, it's just describing where the protection works here between the CPC and the neutral situation, or if the CPC and the main earth in terms of the fixed installation has the voltage, and what measurements and protective measures should be taken.
Right, let's hang on.
And the rest of it is here. If it's used, the measurement of earth electrodes should be located at sufficient distances from earth electrodes and other buried exposed conductive parts, extraneous conductive parts. So it's just carrying on. And this is like I do want to look into again, this 7430, which is where this is all coming from. And we've read this one before, haven't we? Where it says it should operate at 56 volts. Where did we read this before with a separation distance of 2 meters? It says in conditions where only buried, exposed, and extraneous conductive parts equivalent to a vertical or horizontal earth electrodes are being considered, a separation distance of at least 8 meters reduces the voltage transfer from the PME earthing system to less than 20%. And in these conditions, the voltage operated device should operate at 56 volts with a separation distance of 2 meters. Is this where we looked at the distance for electric vehicle charging point TT from PME?
Yeah, it's all connected to it. This is really where changing an existing installation to TT is next to impossible, certainly on domestic and smaller properties, because if you're looking at distances of 8 meters, that's probably going to be impossible on a very large number of properties, because your 8 meters puts you in next door. So you just can't do it. And there's a comment actually from Wayne, I think it was, it's gone off the screen, but said it was looking like everything's going to end up as TT. Well, some things are going to end up as TT, others are going to end up as TNCS with separate foundation electrodes. So,
yeah,
and I think that's where we'll go. We'll end up with foundation and earth electrodes. That's going to be what we do. Dig up the gardens or something. It's going to be.
That's the point, though. You know, are we going to install them in existing installations? Because right now, that's not.
Dave, I think it's fairly evident that there's a lot more thought needs to go into the design, selection, and erection of electrical installations going forward. Amendment 2, even if half of this doesn't go in there, some of it will creep into Amendment 3. We know Amendment 3 will introduce more. This is just going to keep pushing, because that smart tech, that connected grid, is coming. All right, hang on. Excuse me.
722. Actually, not much. There was just this last mention here. And first thing I want to look at is look at this regulation number. 722.826.3.201. So it's actually it's going forward. It's referring to Part 8 here. And it just says, okay, where we have a device complying with 722.41141, this is that TN protection that we've just been discussing, but for 722. If it's used to protect electric vehicle equipment in a PEI, which we've not really covered it yet, but is a Prosumer electrical installation, then the vehicle shall be electrically disconnected from the live conductors of the supply and from the protective earth in accordance with 543.3.3.101 in island mode unless the manufacturer of the device confirms that their device will continue to provide protection in island mode. Okay. We could have really talked about that later on when we talk about island mode in part 8, but that's there for completeness in 722.
Yeah, for those that don't know, the way that these numbers work is that they all link together. So where you've got that thing that says 72.41141, if you then go and look at just 41141, you'll find it's all connected to this, and it's just got the other bit on the front of it. So same with that 826 thing.
The piggybacking of Reg's numbers, isn't it?
Yeah.
Basically,
Normally you go back. This one goes forwards. This one actually goes the other way, which for me as a trainer of this subject is a boring thing that I can highlight because
Just remember, guys, we can comment on this. This is our chance to actually say this is wrong. But remember, if you're going to comment on it, please be polite, no swearing, and give a structured comment of this is regulation. This is what I'm not good with. These are the reasons why, and here's an alternative regulation.
And again, if you have trouble putting it into the right words, there are places like Discord or online, in Sparking Ninja Facebook group alternatively, where you can just ask people to help you word it.
Yep. So, drum roll. Q, like the pun.
Q.
Part 8. Oh dear, just gets worse, doesn't it?
It was necessary to put these in, wasn't it? Yes.
It was.
Completely.
Right, so this is part 8. Now, the deal with part 8 is that it didn't exist before, so everything in this is completely new, or at least it's new as far as BS7671 goes, because all of this has existed previously in another standard. So although it's new here, it's not entirely new in terms of existing in the world, but it's new as far as this goes. So part 8 is functional requirements, and for whatever reason, they've only put in one bit of it, which is Chapter 82, and that's one that covers local production and storage of energy. Now, there would have been a Chapter 81, which was about energy efficiency, which was what they tried to put in some time ago. And there is actually an 83 as well, which they haven't decided to put in either.
It was in the public draft of the 18th edition originally, wasn't it?
It was
81, because I remember doing all the research into energy efficiency. So, but they've just
centres and all
kept
that.
it out, yeah.
So yeah, so of the 3 bits they could have put in here, we've got the middle one for unknown reasons, really.
They're being gentle.
So anyway, it's local production and storage of energy. And this, of course, covers things like the prosumer, which we've seen before. And here's a nice house with the solar panels and the wind turbine. And we've got our connection to the grid on our loads in the installation. We're also going to have battery storage. So prosumer is a word which comes from producer and consumer of energy. And you stick those together, you get prosumer. And from that, we get prosumer's electrical installation, which is basically what we've got in the picture there, is all the stuff combined into a single thing. And that is abbreviated to PEI, which we'll be seeing a lot in the forthcoming bits.
Yes, we will.
Well, is it fair to say, John, that anyone that's got solar on their roof, which is now quite a few million houses in the UK, are effectively prosumers?
They are. And so just earlier today, I went up to one of my neighbours because something had tripped off, and it turns out that they've got solar panels on the roof, which I knew anyway because you can see them, and in their front porch they have some storage batteries wired in some weird controller thing in the middle. So
yeah, it's true, because I mean, you don't specifically have to have storage and powering up storage or anything. If at any time you're utilizing power that you have yourself produced, then that unit of energy has been part of a prosumer installation, hasn't it?
All we're adding here is the producer bit, as in you're producing it, because everybody's a consumer already, as in using energy. So there we go. So PEI is important. So prosumer's electrical installation, it will be coming up quite a lot of times in the future.
Before we move on, I think they've lost their minds in the chat. They believe you've got your Porsche on and that you've returned from a secret mission in the Bahamas, and that you need a peach daiquiri. Well done, guys. It's good. It's late, but it's good.
It's a PV mission, right?
Right. The other concept here, this is the numbers here, by the way, 82. These refer to the things in the book itself. So if you want to refer to that later, then that's the number. Now, smart grids are all about dynamic demand and response. And the key point here is in the diagram is that you've got energy flowing in both directions. So it's not just about supplying energy to your homes and businesses, it's also going to go in the other direction. And the other crucial point here is two-way communication. So this is something which is really missing in most installations at the moment. So your smart home or smart business or whatever can receive information from the grid, and that's kind of things like pricing information and availability and load and all kinds of stuff like that. And crucially, it can also send information back to suggest, like, have you got a lot of extra capacity here? What generation have you got? And all this kind of stuff. So it's not just energy comes in and goes in your house anymore. It's a two-way thing, and it's two-way energy and two-way communication as well. The bit about load shedding at the bottom there, that is a very crude method of saying, basically, if there's not enough supply, we're going to cut you off and you're not going to have any electricity anymore. And that can be either down to the...
There was mention of it in Amendment 1 of curtailment, I think, in 722 briefly.
It's all the same.
It's all the same thing. Colin, yes, they are. Vehicle to grid is the commercial term. We touched on it briefly yesterday, where electric vehicles store power and return it to the grid.
Yeah, we will be getting onto that a bit later as well. So load shedding is just a concept of taking too much power. We need to cut some of it off. So at its basic level, it would be disconnecting your whole house or whole business. But with the smart grid, it's more about turning off certain things within your installation, most of which is going to be things like electric vehicles. So if your electric vehicle is charging and then the grid doesn't have enough capacity to supply that, it will stop charging for a certain amount of time to allow the rest of the grid to keep working, rather than having rolling blackouts and all the things that, of course, nobody wants. So that's the sort of smart grid concept.
And it's not going away as well. This is government mandate. So smart grid is happening whether we want to or not. The whole smart meters is part of it. It's definitely two-way communication to allow local generation and distribution.
Yeah. And the problem for us is manufacturers and companies will go, yes, sir, to government demands. They'll make technology, but they won't necessarily have infrastructure correctly set up for it.
Yeah.
And we're the middleman that's got to deliver a safe system for it.
Yeah.
Yep. We're the ones get kicked.
So yeah, bits of this exist now, smart meters particularly, but obviously there's a lot more stuff coming in, and it's parts of it are already out there, and it's obviously how it's all going to fit together. So there we go. Right. Now, in terms of your prosumer's electric installation, or PEI, there's several modes in which this can operate. Now, the first mode it can operate in is called island mode, and this is where your prosumer's electric installation is disconnected from the grid completely. However, most importantly, it remains energized. So this could be a situation where you've got solar panels on the roof and you've got some local battery storage. The grid, for some reason, goes away or blows up or something, or it's just decided to disconnect from the grid for various reasons. But crucially, your house or business can stay energized, running on its own power. This is completely different to what happens with solar installations now, because if you have solar panels now, as soon as the grid connection goes away, the solar inverter shuts down and you don't have any electricity. So it's about keeping your installation running when it's not connected. And then, of course, the other modes are when you are connected to the grid. So again, prosumer electric installation is connected to the grid. And it says modes because there's two of them. So there's actually direct feeding mode. This is what most people are using at the moment. So the grid is supplying your installation with energy. PEI again, prosumer electric installation. And in that one, you have to actually buy the electricity. It costs a lot of money. And then we've got reverse feeding mode, which is where you or your installation is supplying the grid with energy. So it's going the other way. So from your house and your batteries and your solar panels or whatever, going back into the grid. And the good thing about this piece, of course, is that when it goes the other way, if we go to the next slide, the energy companies pay you for sending them all of this electricity that you happen to have. Now, at the moment, this is not something that happens a lot or at all, but again, in the future, it's going to be totally possible for you to generate your own power and actually sell it to the grid at a decent price. Or even, if there's an excessive generation, say it's a sunny day in August and all the power's coming through, you could charge up your storage batteries in your house on cheap electricity, and then later on in the evening, when everyone turns on their equipment and there's no real generation going on, you can sell the same electricity back to the grid at a higher price and make a nice tidy profit on it.
You can store, you can take it in, you can store it, and then when the rate's different, you can sell it back.
Yep. And the idea there is that it's all automatic. You don't have to actually do anything. It's all handled by the various bits of equipment. So very interesting. Now, these diagrams are out of the book and they do refer to the numbers there. So again, if you want to see this later, you can go and look these up. So this is the types of prosumer's electric installation. Bearing in mind we just looked at the modes and that's how it's connected, but this is actually the types of things you've got within it and what actually makes up a prosumer electrical installation. This is the easiest one, called an individual, and you've got 4 things involved here. First one, which if we go to the next slide, we can see. First one is the public network, or the DSO as it's now called. Previously that was DNO, but it's distribution system operator now. So that's where your connection's coming in from the grid. Then we've got within the station power supplies, which is going to be things like your solar panels, possibly wind power, that sort of thing. So it's supplying energy or things into your installation. Number 3 is load. So that's all the stuff in your normal installation, lights, heating, computer equipment, all that stuff that uses energy. And then the 4th one is storage units. Now, to be a prosumer's installation, you need at least to have one of storage or a power supply. You can have just one of them, but you do need at least one, and you can have both. If you don't have either and you've just got loads, then you're a consumer. You're not a prosumer because you're just basically taking energy away from the grid. So 3 elements inside, and this is just an individual building, could be a house or a business or whatever, that just happens to have installed some of this sort of equipment, and this is the most common situation that we have at the moment. Now the next one is called a collective prosumer's electrical installation. Got the same bits in it, so there's the public network connection, or the DSO. We've also got our loads. In this case we have multiple loads, so this could be a row of houses, or it could be a block of flats or apartments, so you've got say different people within the building. And then your energy supplies or power supplies and the storage are actually in a separate unit, but they can be used by everybody else within the collective. So it's the same idea. And you can remember this one by thinking of it as a Borg collective. So the Borg cube is where the energy and the power supplies are, and the individual units are the drones. So the drones can leave the cube, but they can't actually leave forever, and they're always permanently connected to it. So it's a central point of storage and generation, and then everyone else is
Daniel Casey was on the exact same wavelength there. He put in the word Borg before that slide came up.
Yeah, I insisted that the cube had to move. You couldn't just see static.
So in real terms, this could be a high-rise or a block of flats, and maybe there's a large PV array on the rooftop.
Yeah, that's exactly it.
Okay.
And you might say have a load of, say, storage batteries in the basement, or more interestingly, you could have a whole load of electric vehicles in the basement, which acts as a storage. And then it's all, those things are all then used for the benefit of the whole building or the whole collective. Even though there's only, say, one set of solar panels, it can be obviously for the benefit of everybody there. Just
take a moment and go into the chat. Richard Harrison has asked a random question: are there lightsabers behind me? Yes, they are. Neil has said vehicle to grid won't happen because of EV manufacturers will not allow it. Warranty. Yeah, it's an interesting point.
It's a good point. I mean, I've just searched. I mean, the information we've got, the whole website's filled with Nissan only vehicles. Yeah. But I mean, I think Neil's got a Tesla. I think. I
don't know how many electric cars he's got. He's got a few of them.
Yep. They may not be as welcoming to the idea.
Perhaps E5 could apply to run the DSO. No, the DSO is monstrous, multi-billion-pound organisations. No, don't be silly. We're an attitude. We're not a formal entity.
Yeah. With electric vehicles, the thing is, don't look at your standard manufacturers who you think make cars now. If you want to see where electric vehicles are going, go and look at the Chinese manufacturers of EVs. They are way ahead of the crap that we get over here. Very eye-opening if you go and look at Chinese manufacturers of
Andy Toolkit, which is a great name. I've got a Scalextrics. Interesting.
Does that count? I've got one of those.
Yeah, I know. It's 722 compliant though. Interesting thought. Why change DNO to DSO? We covered this yesterday. Basically, it's the natural evolution of the DNOs because they're no longer operating linear grids. They are smart, intelligent, interconnected systems, and as the network ages, they need to give more license to evolve and expand and control and self-regulate. So DSO was naturally the evolving term. I've been using it for the last 4 or 5 years now because I knew it was coming. Makes sense to. Could you get an advisory roller off Gem then, please? No, is the answer. No. They only care about, the only thing they care about in the electrical industry is actually the tariffs because the general public moan about being ripped off. As far as the DNO is concerned, very little. ENA does that.
Okay.
Yeah, and Steve's put there about the trial of the Nissan Leaf for 1,500 units. Yeah, it is going to be a thing. I'm going to say, if you want to just go and look at some of the Chinese vehicle manufacturers of electric cars, you will be amazed at the sort of stuff that they already have and are actually already using. They are way ahead. They've even got a thing where there's one particular manufacturer of a car in China where you can drive your car around. If your battery runs down or runs low, you can just take it to a station where it's provided by the car manufacturer, drive it in, it takes the whole battery out of the car and puts another battery in it in about 3 minutes, and then you just pay for the difference in energy and off you drive off. And it's all part of the same manufacturer's infrastructure and system. So
it's like the batteries are just like rented or just part of the
basically,
thing.
and that's available now as an end user product that people are using. So
is there any questions in Q&A? Because I can't see the Q&A, sorry.
There's one from Sean about clarifying foundation earthing, DNO,
We'll
DSO,
do it
or
at
actually
the
TT.
end.
We can come to that at the end.
Right, go John.
Right, the final one. This is a more likely one than the collective one. This is called a shared prosumer electrical installation. So it's very similar to what we had previously. It's got all the same parts in it. So we've got on the left there the DNO, or what is now the DSO connection and public network connection. And then we've got multiple units, but each unit contains supplies, loads, and storage, or some combination of. The key difference here is that they all can therefore use energy among themselves. As we had before, you don't have to have all the units. Some can have just, say, storage only, some can have supplies. But in terms of the control and where the energy goes, they're all linked together and actually can share the resources. And this is a very interesting one here, because if you cut the public network at the point shown in this diagram, then those 3 houses, for example, could then run in island mode all on their own as a set of 3 houses, totally separate from the grid. All you've got to do then is say have the public network point at the place shown there, rather than 3 individual public networks coming into the...
John, do you mind me chipping in here? So let me ask a simple question here. Are we at risk of the networks just cutting streets off that have got solar installations and battery installations, saying you're now a private network, away you go?
Probably not, but it is something people could choose to do, and it might be worthwhile doing.
I look at that and I just see broken pens and diverted neutral currents in that drawing.
If you think about it, you can do this on the other types as well. If you had, say, a block of flats, you could have the block of flats, the main intake room comes in. You could then say what comes in there is the public network, and then from that point on, and this is where your building network operator comes in.
BNO,
you can then say all of that is going to be managed within one central system, and therefore that whole block of flats could run in island mode on its own, with its own storage and own solar panels, totally separate from the public network if required. And this is when, say, there might not be enough capacity on the public network, or even if they just decided not to connect to the public network for some reason, because it was cheaper to run it from their own generation and storage.
I think the application of this, there's a lot of work. I think this part 8, I mean, we're not even through it yet, but there's a lot of work, a lot of understanding, a lot of normalization of this knowledge and these terms that we have to go through.
So the point about these is it's not necessarily what you can do, it's what you will be able to do, and the possibilities of what you can now do with power and where it comes from and what you do with it are just absolutely massive. So that's shared, and I say it's basically just a group of individual units that have decided to work together. Basically all it means is they've got their control equipment is all linked together, and it can determine where the energy is going, who's generating, who's supplying, and whatever. So that is that one. Foot or a train station, yeah, absolutely. I mean, if you've got a railway station with solar panels on the roof and batteries in the back, and yeah, why not run it in island mode? So
yeah, well, in fairness, Gray's station actually, we produce more than we're actually using from the grid. So
you may even have a sneaky generator you didn't even know was there.
Yeah, well, Terry's just put, so had a diesel generator, you could turn it on and sell back to the grid. Yeah, in theory you could. That's not probably going to be encouraged because that's burning fossil fuels, but yeah, it's all possible.
Should we go into EAMS?
EAMS, what's EAMS?
EAMS is Electrical Energy Management System.
Ooh.
EAMS, yes. Now, this is an important concept, because this is the equipment which connects all of these things together. So your solar and your storage batteries and your electric vehicles and all the loads in installation and all the metering equipment and the communication and all that stuff, all wrapped up into a nice little 4-letter acronym. And this is the bit of equipment which controls all of this stuff and therefore decides what's turned on and what goes where and what's going on, basically. So there's a lot of text in the Part 8 about this, but in summary, what it does, it's managing the connection of the prosumer electrical installation to the smart grid. So that's turning it on and off and doing whatever. Manages local energy production, such from your solar panels, things. Manages local energy consumption, and it manages energy procurement.
Mm.
Now, in terms of consumption, what this ties into is load shedding. So, for example, you might have your electric vehicle plugged in, and it might decide that there's not enough solar power coming in at the moment, so it's going to turn off your electric charging for a while. Perhaps some clouds run past, and then when the clouds come back, or gone away rather, lots more solar energy available, you can stick it into your car. And it can do that theoretically with anything else that's smart connected. And in terms of energy procurement, that's buying it from the grid, what price is it, what's the availability, and of course selling it back to the grid as well. Again, what price is it, what can you get for it, is it worthwhile?
John, this kind of links in, doesn't it? Because smart meters, everybody's been talking about smart meters switching people off, acting as a load shedder. It's managing local energy consumption in line with a smarter grid. And this is the problem. So nobody wants smart meters. I don't want a smart meter. But looking at Part 8 and the logic of controlling prosumer's installation, protecting the natural diversity of a smart grid, it makes sense to have a smart meter, because then you'll effectively have a central DSO operating and controlling and managing that system.
Yeah. I mean, unfortunately, smart meters are an inevitable part of this whole idea.
Yeah, we can't dodge them all the time.
But,
and I'll try, or at least another 10 years. I'm going to try dodging them.
So with that procurement part, is that suggesting there that you could maybe set your system to identify the lower peak demand or the lower cost tariff, and then actually take some supply to store up your batteries?
Yes, absolutely.
So you could top up your batteries when it's cheaper.
Yes.
And obviously when the peak goes higher, you could then switch to your stored energy.
Yeah. Now this is something that happened earlier this year, which I think was either April or May, when the all that lockdown thing was going on. It was extremely sunny and there was a lot of wind. And the load on the general network was actually very low because nobody was going out to work. And what actually happened then was that for a short time, the electricity price actually went negative. And which means basically that there was so much generation being shoved in, it was, if you were able to take energy, you were actually being paid to use electricity. And if you had an account with a company called Octopus Energy, I think it was, or one of the others, but one of those companies, and had one of their weird tariffs, they were actually paying their customers to use energy. So if you turned your tumble dryer on, you could get £5 or something like that.
Jesus.
It wasn't for very long, but it gives an idea of the kind of strange things that can happen. So all that solar and wind energy piling in, what are you going to do with it? You've got to do something with it.
Yeah,
so it's like, here's a £5, turn your tumble dryer on, or here's £10, charge your electric vehicle. So yeah, the possibilities for getting energy at very low prices, or even for free or below free, and then storing it and then using it later, or even selling it back to the grid at a high price, it's all there.
My fear in this, John, if you don't mind me saying about this, Eames, is some Andy Toolkit, great name, possibility of getting to a point where a glitch in your Eames electronics would result in you having no power, just like modern cars. We have to wait for computer diagnostics to get the fault corrected. He said, I'm going to invest in a generator. Now, interestingly enough, he's kind of right, because you take your car to a garage, you rarely get a mechanic now. You get a bloke with a computer who plugs it in and diagnoses it.
Yeah.
Now, this is not great for manual trades, because you're now looking at encouraging people to go into electronics and software and diagnostics rather than hardcore pipe, bending and wiring and all the rest of it. So this is where leveling up, using a term that somebody on this uses frequently, we, especially for the dwelling installer,
whatever that is,
dwelling installer.
Some of the comments here, it was Octopus Energy. I thought it was there. They're basically one of the only companies that currently do this. And obviously you need a smart meter for it.
I'm going to sign up to Octopus Energy tonight.
But at the moment, it's a fairly it's not totally automated, but the idea with this in the future is that all of this could be fully automated so that your electric energy management system would deal with all this for you and make these decisions in terms of where the energy is going and the most efficient and cost-effective use of it. And yeah, so we're kind of just going into that now with, say, one energy company, but eventually this is where smart meters will go. I mean, my sister has a smart meter, and in the documents for it, it actually says that it has 128 energy registers in it. So that potentially means 128 different prices that it could actually utilize.
So is this one central system? Because I mean, Neil's just pointed out that smart battery systems already do this. I know that companies like is it one of those vehicle chargers? They've got this the Zappy or whatever, that you can see an app where you can see your in and your out and all this stuff. So you can just see energy move in different directions or how it's collected. Is this just going to be a new meter?
It could be a central piece of equipment, but it's more likely it's going to be individual pieces of equipment that all communicate with each other.
Yep.
So some of these already exist. So the smart meter is part of this. Those Zappy chargers are basically one of these already.
Yeah.
And the whole idea is that all of these devices can then communicate with each other and make collective decisions on what's the best thing to do and what's the best time to charge this, turn the washing machine on and heat your water heater and all of this sort of stuff. So it can be just a big sort of computer, if you like, connected to all the stuff, but it's more likely going to be individual pieces of equipment that crucially communicate with each other, and the end result is the most sort of efficient and cost-effective use. And crucially, to keep the power on, so if you've got, say, huge demand on the grid suddenly, it might decide to switch into island mode because the grid's being overloaded. That means your lights things stay on and you're running your power, and that also helps everybody else because then you're removing yourself from the grid and not putting a load back onto it.
With this, is the agenda here primarily to maintain the integrity of the infrastructure of the network, or is it energy efficiency as would have been with Chapter 81?
Energy efficiency is part of it, but most of this is essentially there to make sure that systems keep working and don't
to
fall
protect
down
the network from flopping.
Yeah.
Okay, because 81 had all those other stupid ideas to save money and save energy. This is more the system. Okay.
Speaking of 81, at the bottom of the screen there, we've got C Annex D82, which covers a bit more of this. Or you can look in BSHD 60364-8-1, which is what would have been 81.
Yeah.
And of course, you can go and get that standard, but is it? Of course, it's not actually free, is it? No. So if you want to get that, you do in fact have to shell out a pile of money. So if we move on to the next slide, there you go. So as usual, it's stuck behind that paywall, and you have to pay. I think it's about 200.
You mean the Broken Standards Institute? Now, interestingly, if you want to know what's coming even further, 60364-8 Part 2 and Part 3 are consistently developing, and when you go down that rabbit's hole, you can see that there is a lot of synchronization between car manufacturers, EMS systems, etc. It's all part of this government and DSO big strategy and vision. The one thing I will say is it is quite... Never has there been a more interesting time to be an electrician, because guys who have served a long career with resistive and inductive loads, holy cow.
I agree with that, but I think a lot of electricians right now are at a fork in the road, but it's not a fork, it's going in all these freaking directions.
Yeah.
And a lot of spots just don't know what the hell to...
Well, we're not a regulated industry.
Everything's going in so many different directions right now.
Yeah, some of the comments before we go on, Neil Bridge put their CT clamps everywhere. Yeah, it is going to be that kind of situation. And if you have a look in the Annex D82, which is not in this presentation because it would be too long, it's got some diagrams of how an EMS would actually fit into an installation, and it shows metering in 5, 6, 7, 8, 9 different places throughout the installation, all linked together into this bit of equipment. So yeah, absolutely is going to be that.
It's got to know what it's got to know what it's going to know, isn't it?
So energy monitoring and all this sort of thing is a big part of this.
Is this why there is rumours of a Schneider Rcbos power tag domestic version coming soon?
Well, could be, because that kind of stuff is going to be needed. Even
I said out loud.
And large issue batteries, what they can discharge at, most producing only 20 amps, short at 25. Yeah, that can be an issue. However, think about your typical load, certainly in domestic, there aren't that many things that use high current for a length of time.
For time, yeah, for lengths of time, not like...
So it's
Inrush, isn't it?
possible to run most of your domestic stuff on pretty low current. Things like electric showers, of course, are going to be a problem. But then generally, I think in the future, electric showers are not going to be a major part of most people's installations.
Some of these, I mean, obviously electric boilers, which we're going to be going to look at soon, because obviously gas is going to be
Phased out.
They're quite efficient, some of these electric boilers now.
Yeah, my opinion is electric boilers are a temporary thing only, and they're not really worth going into, because eventually it's going to be heat pumps, air source particularly. Because if you've got all this energy and you're going to stick it into direct electric heating, as in a heating element that heats up, why would you do that when you can buy a heat pump from someone like Mitsubishi, which will use about a third of the energy and give the same heat output? So, yeah.
Daniel Casey says phasing gas out is stupid. Don't worry, when they do, all the gas engineers will do a 15-day course and become electricians.
Yeah, I mean, gas, although the government's trying to get rid of gas, it's been trying to do it for years, decades, in fact. And even if they get it through this time, all that will happen is that it won't be allowed in new build. So, of course, that still leaves the tens of millions of installations with gas already. They're not going away. Electrical boilers the future. Well, I'm sure certain manufacturers have claimed that because they make them and sell them. But it's my opinion, not the regs, but it's my opinion that direct electric boilers are not going to be a big thing. The main problem with electric boiler for a house...
They tried them, didn't they, in the early 2000s?
Yeah, you need a massive amount of energy. If you've got an electric combi boiler, you're looking at 12 to 16 kilowatts.
Yeah.
Switch that on, it's going to put a massive strain on the system. Half the domestics now couldn't even cope with that as they are now. So...
Neil put a valid comment. The gap between 7671 where you're teaching at is getting wider. Agree beyond belief, but that's Dave's monologue at the end. Your final thought.
My final
domestic
thought.
is a proper skill now. Do you know what? Domestic has always been a skill. Dwelling has always been a skill. I'm going to really love that, but it always has. The trouble is we've come up in rail, industrial. Every time you go somewhere, it's almost like serving your time again. And domestic for me has always been a skill. You just get good at it. You repolish them skills. You're in a confined area, but it's a skill. Now it's getting really complex.
I think the problem with domestic, certainly in the past, it's been very easy for sort of people, for a better word, to just lash the same old stuff in and not really give a care about any of it. There's no real design or consideration in it. But
well, again, with books like the On-Site Guide, which give us pretty much a template strategy, it's been simple, but everything's getting a lot more complex now.
But yeah, I mean, domestic isn't just lashing in a couple of rings and a lighting circuit anymore. Those days are basically finished. So there we go. Right. Now, what we just covered
this is John. Hang on. This was John's back garden when he was mucking around some Tesla coils. Just to clarify that image. Sorry, carry on, John.
Yeah, what we've covered up to now is basically it's basically definitions which are out of part 2, which is why we didn't cover them in great detail yesterday.
Yeah,
but they're in part 2 if you want to read them. This is more the sort of technical issues which occur when you start having prosumer installations, and most importantly, where you're not just having power coming in. Now, the first one of these is that operating modes can change at any time. So remember, this is the island mode or the direct feeding mode or the reverse feeding mode. And protection, as in protection against electric shock, must be effective in all of these modes. Now, just think about this.
It's a little bit like where you have a generator operating as an alternative and you have that automatic switchover.
Yeah, it's a similar idea. The difference here is that it's quite likely on a prosumer installation that it's going to change modes quite often, several times a day, maybe even several times an hour. So whatever you put in protection, as in circuit breakers, RCDs, and whatever else, it's got to work in all of the modes all of the time. So it's not going to be just a question of sticking a thing in the consumer unit and hoping, because
I just love.
Hang on.
I just love that
section prayers is not a section in the certificate, no.
I just love that section 826 is called technical issues.
That's great.
Good, isn't it?
Very good point.
Yeah. So, whatever protection device you're putting in have got to work in every operating mode of your installation. And the idea is that could and will, in fact, change.
Again, switches a different supply source, different fault characteristics.
Yeah. So, as a quick example there, if you've got a grid supply, then you're going to have, say, TNCS, you're going to have typically very high fault current, very, very low, whatever they're calling now, earth impedance or earth fault impedance. However, once you go to island mode and you're supplying from batteries, it's not going to be a high fault current anymore. It's going to be very low, and the impedance is going to be considerably higher. So think about that. And then, of course, you have the situation where you're using multiple devices at the same time. And yeah, exactly. So anyway, we'll move on. So the earthing type may change depending on what mode you're in. So if you go from feeding mode when you're connected and you go to island mode, the proposals state that you will need to have an earth electrode, or more likely some kind of grid or mat or whatever we've got shown there. You will disconnect from the public network, and this is all of the live conductors disconnected. And then there's going to have another device called a neutral switching device, which connects the neutral and earth conductors together at the origin. And the reason it needs this is because if it doesn't have it, none of the Rcds in the installation will actually work.
So the normal incoming supply, when you switch over to your island mode, the device that isolates has to do both live conductors simultaneously and at the same time connect neutral to earth.
Yes. And the two switching operations can't overlap. So there's got to be a certain amount of space between them. So it can't obviously connect neutral and earth while the grid is still connected, because obviously that's not something we want to happen.
We have a slide right at the end of this that I left in, which we can maybe use as a discussion piece during the questions at the end.
Definitely look at that later. So you could go from having one earthing system to a completely different one and then back again, and say in theory several times a day. So often. And this really follows on from that. So we've got earth fault current, different systems, so TN, TT, or even IT, because that is a valid operating or actual earth system.
I have a feeling IT systems are going to come back quite readily.
Especially if they're removing RCD, if they're enforcing RCDs, what's your alternative?
Yeah. And for those who don't know, IT does not mean computers and information technology. It means insulated or isolated from Earth. So that's essentially a system which doesn't have a connection to the Earth outside, or if it does, it's through a very high impedance.
Which, believe it or not, used to be railways years ago.
Oh, well, there you are.
There you go.
I was doing some research on it, and many years ago, in the early days of electrification, everything on railway platforms were connected directly into the traction system and not to the DNO, which made all the platforms an IT system. There you go. Sad bit of knowledge.
So the earthing system could be different for each mode, and because of this, you might need two devices for fault protection. Now, it actually says this in the section 82611. In theory, you could have two separate devices, or more likely, it's going to be a single device with two types of protection in it. I don't think having two separate devices is a particularly valid.
Well, John, you'll have to, when you're doing your selection erection, you'll have to consider each mode, won't you, and select a single device that achieves compliance with both.
I'm going to say, otherwise you're going to have them in parallel with each other. I mean, how is that going to work otherwise?
It'd just be a cluster.
It's shown in the diagram as two devices in series in different points of the installation.
So one has to tolerate the conditions of the other.
Exactly. And you've got to cope with something being TN and TT, and then to go back to TN. And yes.
Yeah.
Hang on a minute. Can anybody hear the music from the Twilight Zone? This is.
Yes, Terry Austin has put a very good comment, says that's going to put loads of strain on switching devices if they're switching multiple times a day. Yes, absolutely right.
It will.
Coming up to that shortly. So,
David Graham has nailed it. This is going to be a qualification in its own right. Absolutely. Mr.
Extra
Pete's
30 minutes on your
brother.
3-day regs course.
Well, I said the other day this should be a 5-day course on its own.
Yeah, this will be. I genuinely agree with that, actually. I think there's a 5-day
There'll
one
just
here.
be 4 more questions in your exam. That's all you've got to worry about.
I actually think this is one of those courses that actually should have rigs and practical knowledge given over it with some actual products that you
Andy
can
says, commonly used in operating theatres. Yes, IT systems.
Yes.
Yeah, because they stay in operation in the first fault condition. So, yeah,
Indeed.
essential.
And Richard Harrison, have I lost years? Where has this all come from? When I started reading this, I had dark hair. So
there you go.
Yeah, there you go.
That was 50 years ago, wasn't it?
See you, Eddie.
So,
Hi, Eddie.
Right, this will obviously be on YouTube as well if people want to fill it in later. So this is still on protecting against shock. Isolation of the installation, obviously is something we do now. It's nothing unusual there, but each source must be isolated. So this is each source of energy. You also need to consider isolation from the public network. And then, as you've got multiple sources of generation, this raises the question of where is the origin of the installation, and can the origin change depending on what mode you're operating in?
Well, I had this thought yesterday when we talked about certification. Surely your system would have two sources of origin or two sources of supply, unless we documented it as two separate systems.
We should already be looking for this now, different sources of supply. But yeah, where would you define the actual origin? Is it at the, say, the PV array? Is it the battery storage? Is it
It comes back to the question of what is the system?
Yeah.
And if you've got one final circuit that operates on two separate sources, then that one final circuit configuration is great. But if you've got two different supply characteristics, then you technically have two different fault conditions. So you've got to document them together.
Wayne Rodis Clark has put a very valid point. I can see this splitting off into a specialized area. I think, Wayne, at this point, this is new for all of us. So when we read this melted our brains as much as it's melting yours now. I don't see it becoming a specialized area because this is the dwelling installer's job now. It's going to be really interesting to see how well they do. But like with any adoption of anything, like PV 20 years ago, early adopters, embed, find out what's wrong, adapt. We're only now getting to the point where PV is a stable technology. There's lessons learned. This is a generational thing. Each generation of sparks will get better and better.
The thing to remember here is the government with PV is a good idea. They gave us a feed-in tariff to incentivize. This is going to be a lot more firmly pushed.
Indeed.
For new installations.
Okay.
And existing.
Carry on then. So protection against overcurrent. This is the thing that normally causes fires and overheating. So nice fire there. Things you've got to consider: short circuit current at all points of the prosumer's electrical installation. Direction of the current and polarity, because when you've got different supplies coming in different places. A combination of all of these power supplies connected at the same time. So you could quite easily have a grid connection and solar powers and a wind turbine in the garden and the batteries supplying and taking. And also the location of the fault relative to where the power and things is actually coming from. And is the device you're going to hopefully protect against overcurrent actually going to disconnect what you think it's going to disconnect?
So, I mean, when you're testing this or you're designing, you can design this and you're going to test this, you're going to want to have both. You're going to test it under one situation with one supply and under the other.
Yeah.
And again, you're going to verify the short circuit current at all points. It's mentioned here. Why can't they just throw that into the bloody paperwork?
Slowly. Bit by bit.
Right. This is 8613, outage of the public network. So some kind of power failure or the basically the grid has gone away. Two choices: island mode, or you can just disconnect all the power and put a candle on instead. Now, if you've got the local storage, island mode is probably going to be the preferred option because then it keeps all your stuff working. However, if you didn't have enough battery storage left, then disconnecting everything again is an option there. And then we've got duty requirements for switching devices, which is what was mentioned earlier in the comments there. As yes, it is going to put loads of strain on switching devices. A lot of these devices out there now are designed for temporary use or standby use. And they might only be used, say, once a year, which is when they decide to test the generator in the basement and switch over to that. But say these things could easily be switching multiple times a day. So you've got to consider when you're actually buying this equipment, is it actually up to the job of switching potentially thousands of times a year without blowing up and melting?
It definitely shouldn't be considered as a standby switching device. It's more of a functional device.
So, chaps, just on this, we mentioned it yesterday as well. There's a standard ENA standard G55. And that is that's an interpretation of the EMC directives, and that's to deal with connected loads, switching, transients, harmonics, because the stuff we're producing now in this smart form is having a detrimental impact on the grid. So they need to manage it somehow, and G55 has come out, and that's a method and interpretation that slowly will be working its way into all of this for all of these switching, producing harmonics. We're not exporting smooth waveforms anymore; they're inverted. So it's a different world. UK grid considered extremely stable. Well, not if you were on the webinar last week, it weren't.
It is. I mean, it's reliable at the moment, and it doesn't just sort of go off every 5 minutes.
Yeah.
But all of this stuff is being attached to it, and the whole grid the grid as a whole is moving to massive amounts of generation from solar and wind,
Yeah.
which by their nature are intermittent and unpredictable.
Yeah, I mean, there are power companies around the world that have really championed this. I mean, I remember when I did some studies looking at 722 on curtailment, I came up with examples of places like, cities in Africa where they actually at a certain time of day will just shut off, what we would consider to be a small city. Now they just shut them off because the main manufacturing and the area of hospitals and commerce need the power, and so places are just shut off at nighttime or peak times of the daytime.
To protect the grid.
Over here, we haven't got that problem yet. We've got a much better system, but there's still nerves about continuity of the system with the amount we're intending to put onto this grid.
Yeah,
especially with electric vehicles.
And again, all this equipment exists now. It's not some future thing that's coming in 10 years' time. You can go out and buy this stuff now, and there are installations out there already installed in the UK that do all this stuff. There's a fairly big one in Oxford, I think, somewhere.
See, Simon,
doing these things.
Yeah, it's true.
Right, transient overvoltages, which we have mentioned several times already. And this is about when you're switching between sources and load shedding or disconnecting loads you don't want, and of course switching between modes as well. All of these switching actions are going to create transients on the system, so surge protection devices will be required on any prosumer's installation. So no real surprise here because they were probably required anyway, but these are going to be required purely from the switching transients, nothing to do with lightning strikes or lightning strokes. So once again, surge protection is going to be a thing. It's going to happen. It's going to be everywhere. Fit it as standard. And let's have a look at the comments there.
Sorry. Daniel Quace is quoting 26 of ES electricity safety quality continuity regs, disconnection of supply, refusal to connect, and resolution of disagreements. Yeah, that's one I've. Don't get me started.
Yeah, that's
that
the old one about interference with the system, but. All of the equipment that connects should comply with a whole pile of stuff, which I think we'll cover a bit later on. There is a whole website which we'll also look at, or at least give you that.
A quick one. Wayne Roddis Clark, switching under load at multiple times. It's going to be some switch along with SPD, AFDDs, etc., etc. These installs will need some major training and be rather pricey. And that's a bit we should talk at the end, exactly costing and who's paying for all this and the consumer and how we promote Sparks trying to do the best endeavours and the best selection direction without pricing themselves out of a business.
Yeah, the one above that from Raphael says, we lost power to whole villages trying to hear multiple times last week alone. Stable is not a name I would use, referring to the grid there. And we have our own solar farm, which we're connected to, and it shut down as well. And yeah, that's kind of a big disappointment, really, with some existing solar, in that if the grid goes away, the solar stops working.
There was a webinar a couple of weeks ago with some grid guys on it, and the national grid is pretty stable, but the DNO networks are, there seems to be an issue with fires due to harmonics and heat in the cables and various other issues caused by the importing of unstable harmonics and frequencies and trying to match a sine wave on a system that's
it makes
varying.
sense though. If you think about generation and transmission, the area where the frequency and the sine waves and all those are going to get chopped up and moved around is right near where the equipment is, and that's where the problems are going to be, right at the end of that distribution line.
Yeah, Neil Bridge put there the Powerwall 2, that's a Tesla thing, I believe. Covers all the switching internally. Yeah, that's exactly it. So that is an example of product that's been designed specifically for the purpose. It's not something that someone sort of think, oh, this is fine, it's some standby switch, we'll just shove it in. So yeah, again, if you use equipment designed for the purpose, there's not going to be a problem.
I'm definitely going back to doing penny for the guy then. $7.5 for a Powerwall. Oh, I'll never afford that.
So anyway, interaction with the public network. Prosumer's electric installation to comply with the supply requirements, which is things like voltage and frequency, and also the harmonics and all the other stuff we just mentioned. This is in Annex C82 in the draft there. And there's also a website which Annex C82 basically says, go and look at this website about 10 times in a row. So basically, just go and look at it, decode.org.uk. And astonishingly, this website is free, and you don't have to pay to access it. You can just go there and look at it anytime you want. So well worth a look there.
Distributor's code, yeah, absolutely.
That is it. Now, 86.3 is energy storage. Primarily, it's going to be batteries. And it says here you should consider inrush current and other capabilities. when switching between modes. Now, I couldn't determine what other capabilities actually meant.
I'm hoping it makes you a bacon sandwich in the morning. I don't know what other capabilities are. What do they do? Does anybody know what other capabilities of batteries are?
It wasn't clear. I mean, inrush current fine, because obviously when you turn things on and off, that's where your transient things come from. But other capabilities, and that's all it said. So
we'll do some fishing on that one.
If anybody knows what the capabilities might be, then please do put them in the comments or whatever else. So
Tom Grimes has said he was talking to someone today and they have a Tesla Powerwall and installed it in their hallway.
Yeah, that's not a place I would want a battery storage system, but
no.
Although I did go to one of my neighbours today, and they had a couple of battery packs sitting on the floor in their hallway and underneath the solar inverter and a lot of other gear. So yes, interesting times. Right.
Neil's just said, would this new Section 8 cover UPS systems? I think we briefly touched
the
this
answer,
yesterday.
We talked about this.
No.
Yeah, the answer is no. The Section 8 is purely about prosumers electric installations where you've got all of these generators and storage things, all of which are connected pretty much all the time. It specifically excludes standby systems, UPS, and that type of thing.
Yeah, that stays in 55, doesn't it? Generators
already covered in other areas. So it's not about temporary power or standby systems or pulling a generator out of the shed and plugging it in once a year.
I do think, John, eventually it will start merging. I think given time and amendments and 19th, it will eventually work its way.
Yeah, absolutely. But at the moment, it's distinctly separate from standby and that type of thing.
There's a lot of work to do.
So flexibility load and generators, designed for operative load shedding. Doesn't say much about this, except if you want to know about it, go and look at that lovely standard again. That's 603648-1. And of course, again, you have to pay for it. So what a surprise.
Yeah.
Yes.
This is ridiculous.
And again, they could have put that in this particular one because that would have been Chapter 81. They could just put it in there.
That's annoying because it's just continuity. That would make more sense.
But it's not in there, so why? Right, electric vehicle charging, 826.5. This obviously already exists because electric vehicles do exist. That thing there is a Nissan Ariya, I believe it's called. You can't buy that yet. It's coming out next year. Electric vehicle charging is an interesting one because it's both a load, as in it takes power from your system, and it's a storage device, as in it's got batteries in it. And of course, it can also put power back in with the vehicle to grid. Obviously, it's not permanently connected because it can go away and be driven somewhere. I certainly hope so. And the key point, it should be managed by the EEMS or the Electrical Energy Management System we saw before. And that could be the charging point just links to some central management piece of equipment, or as we saw before, it could be just the fact that you've got one of those Zappi chargers or something similar. Some of the functionality is built into that, and then that will communicate with things like your smart meter and other equipment to achieve the same end result.
John, is it fair to say this is definitely an emerging development in the world of dwelling installations?
Definitely.
I love that nature.
And in terms of electric vehicles, particularly if you have it done under the scheme that the government's running about, you can get your £350 grant or whatever, you must have a smart charging point installed. You can't have just to plug it in and it works style. I've actually said that it has to be a smart one and it communicates with whatever else. So already going down that route.
Incentivize.
Now, selectivity, called discrimination until fairly recently. Principle is that your downstream device operates, so that would be a 3 amp fuse, and the upstream device, as in your circuit breaker there, 63 amps, does not. So that's fairly well established. However, in a PEI, what is upstream and downstream? Bearing in mind you've got
current goes both ways.
Yeah, you've got different sources of energy coming in. So where are you going to put your protected devices and how are you going to ensure selectivity between them? And bearing in mind where the direction of the energy is going can change depending on what mode you're in. So this is just another big pile of problems to consider.
I'll stick with industrial.
I was about to take up plumbing.
Yeah.
Okay.
You don't want say, your main intake fuse or whatever to go out just because some piece of equipment in the installation, like your battery, has decided to go on the bust. So
can we not just go back to cartridge fuses in boards again?
Well, cartridge fuses are still valid. You can still fit them.
Yeah. I miss the fuses. Sorry, bit nostalgic there. Right.
And 86.7 is testing and verification. Loop impedance test instruments may not work properly with inverters. Now, we kind of covered this briefly before. And if that is the case, you may have to use alternative methods of determining loop impedance and fault current.
Jesus wept. Yeah, I don't agree with that one.
Okay.
Just make it up. No, don't agree with it.
So the alternative method is calculation. Is that what they're saying?
Pretty much. It didn't actually state which it was, but yeah, it's going to come down to calculation and things like specification of the transformer and all that kind of stuff.
Again, it depends on the inverter manufacturers, whether they want you doing. I mean, I've grown up working with UPSs and inverters, and I've always done a test on the mains with it in bypass and a test through the inverter, and you normally got between 3/4 of an ohm added onto it, but I still wanted to check the performance and the safety of the circuit, as I would do. So I had 2 ZS values. This, I would never calculate it, but I'm well aware that some manufacturers say, please don't put 23 amp high current tests through my equipment.
Yeah. And
there must be a way you can just temporarily bypass.
Well, the MFT 1741 Plus apparently has got this confidence meter, and they have said that it will work on inverters. It will filter it out and give you a reasonably accurate reading. There are videos online of that.
Yeah. Another problem with this is that the loop impedance itself will change depending on what mode you're in and what actual energy sources are coming in. So it's definitely not going to be a question of plug it in and do the test and that's it. It's going to be plug it in and then check which mode you're in, do a test in that mode, temporarily switch it to the other mode, do a test there, put different types of sources, generation coming in, your solar's coming in, your batteries are coming in. So there's going to be a lot more testing or this sort of suggested alternative. But the problem with alternatives is if you're going to calculate it, it's only going to cover a very specific situation and it could be wildly off. So,
and John, also one of the issues that we found a lot on industrial, when you're measuring the fault current levels for the protection device to disconnect, you need to have sufficient fault current levels. When you go into battery systems, unless you have an inverter that's able to deliver said fault current levels, you may not get the protective device tripping. It's one of the biggest issues on UPSs, where the inverters are too small because they run, say, emergency lighting, but it's connected to a board, and you have, say, a C10 amp breaker, you need 100 amps to trip, but the inverter can't deliver 100 amp, so you're never going to get your breaker trip anyway. So there's lots of things in consideration we need to think about when we're working around this technology, including not blowing anything up.
Yeah, and don't think RCD is going to fix all these problems, because it's not just faults between line and earth. If you say have an overload between line and neutral, if the inverter can't supply enough current to trip the device, you could have too much current going through your cabling, causing it to overheat and set on fire, and that can still obviously not, the device won't trip because it was designed for something with a much lower loop impedance. So
yeah, so sizing the inverter is key. I think everybody's brains are melting. Neil Bridgman has said perfectly, sod doing EICRs. Imagine the amount of EICRs using part 8 on an existing installation that you know to be a prosumer. My God, they're going to hate that report.
Yeah.
They're going to hate that report. So yeah, this definitely needs a bit of embedding, but it's good to talk about it because, guys, this is where it's going.
Ben Pearson's got a good one that says earth fault loop monitoring as part of the management system. Well, yeah, that's not actually mentioned in there. It's a very good point.
I have suggested this to manufacturers about consistently monitoring the earth fault loop impedances, getting a device that does that onto the mains, but I'll talk about that on another webinar.
Yeah.
And definitely no 5 a day EICRs using this.
No, 5 a year might be near the mark. So just, right, there are some annexes in this section. We're not actually going to look at those in detail because we've actually covered most of it. A82.
See, Richard.
Objective concept, covered it already. B82 is the operating mode. That's quite a good one because it gives you a whole selection of diagrams of various types and it shows where the energy can flow in and out and various things. But again, we have covered that. C82 is the one that covers interaction with the public network. And as we saw before, that's basically, it just says, go and look at this website about 10 times in a row. And D82, again, that's quite a useful one because it has a lot of diagrams in. And again, it gives examples of how the prosumer electric installation and this electrical energy management system can fit together. And again, it shows like metering devices put in and there's different configurations of that. So we're not going to look at that here because assuming the BSI site is working, you can hopefully go and look at that yourself.
Be broken.
Broken, yes. So of those two, if you're going to look at it, I'd suggest you look at D82 definitely because that's nice dot diagrams in that one, and probably B82, and the other one just go look at the Decode website for the things of how it connects or interacts with that.
Okay.
Now, that's the end of that bit.
That is the end of
Well,
that bit.
the thing
So
to
let's do
remember,
some questions.
the thing to remember is we had already been looking at 60364-818283. I looked at this back when 18th edition was first coming out in the public draft, and I looked at energy efficiency. But this, what we've covered, is just what we've done in the pace of a day, really, because we didn't get much access to it today.
Yeah.
So
yeah, today's been a write-off. So this is yesterday's.
Yeah.
Divide into three and just devour those parts and try and put some interesting images to them, which is, I can tell you now, when this is done, I'm going to bed because I'm absolutely mullered.
So, I mean, we've got some understanding on this ahead of the curve, but we've had to obviously say it as it is here. But we are going to do a lot more digging. The guys in Discord will do that as well, and we'll get some thoughts together, and we will revisit this.
Cool.
Not tomorrow, but in a while.
Yeah, we need some time.
But we'll do it way before the end of the comment period. Yeah. We will do something just to kind of go through it, just to see if we can offer some more reference points and some other interpretation. Because it's a lot of information.
Before we go into the Q&A, Dave, can we just jump ahead a couple of slides? Because we had some extra stuff in here. So this, we've talked about in previous webinars, broken pens. Now, if you do a bit of Googling, you can find some old manuals from Schneider, Merlin Duran, and this is quite an interesting slide we wanted to just highlight. So if I can get my mouse over this, this is an old square D with a fly-lead neutral and functional earth. But at the bottom here, it says trip mechanism, loss of neutral protection. Device will trip on loss of neutral and is sensitive to both AC and pulsating DC. Device will trip on voltage between neutral and earth greater than 50 volts. So this technology, this OPEN, this measuring rise in voltage, has been around for donkeys. And it's actually, I've just been told by Schneider, it's actually in the Isobar P, which has got your functional earth, because I've highlighted the earth and the neutral there. I don't know if anyone can see it on the screen. And apparently that is still in their technology, but we are awaiting some confirmation from some gurus on RCDs Global to tell us more.
The thing is, we like a standard, like with AFDDs, we're like 62606. Have we found a standard that covers?
Well, we found the reference, which we referenced today and yesterday, which is interesting. There's two categories of RCD mentioned in the Schneider document. In the event of a loss of supply required to address the fault and trip, there are two categories of behavior. Category 1, the RCD does not open and continuity service is optimum because the load is powered on when the voltage is restored. So that to me is like latching, non-latching, etc. But the RCD is unable to operate if the loss of power supply is a result of a neutral break. The presence of line voltage is a hazard because the RCD is no longer able to perform its protective function in the event of contact with the line potential. A category 2 is the RCD opens if there's a loss of power supply, which I like straight away, including in the event of a neutral break. Good. After the voltage is restored, the RCD must be reclosed to power on the load again. That's why I said latching, non-latching. To improve the level of protection provided by category 1, in the event of neutral break-in, I'm talking about broken pens here, the product is supplied by redundancy via the functional earth, line to FE supply instead of line to neutral, allowing it to continue to perform its protective function. This configuration allows the behavior of a voltage-dependent type RCD to be compared with that of a voltage-independent type RCD. Now, if that isn't melted your brain, I don't know what does. But it would appear this technology exists. And yeah, that's pretty much it.
So what device did you say it was already in?
It's in the Merlin Duran Square D stuff, anything Schneider, basically.
So, all right. So is it in a Schneider AFDD?
I don't know, because we only asked Schneider the other day and they are awaiting their experts in Asia to get back to us.
Yeah. Because it answers a lot
Probably
of questions.
A question they never expected anybody to ask.
In fairness, my words to the people at Schneider is, can you please tell me this in English? And if you tell me something, I'm going to ask you again, tell me in English, because we need to know. So, for instance, on my Isobar P here, if I highlight this, you'll see that there is a functional earth and neutral connection, which plugs into the buzz bar. So my question is there a link or a switch when it detects a rise in voltage on the neutral that links the neutral and earth? Now, we've just mentioned it in part 8 about linking the neutral and earth, but are they being done in the boards and the protective devices? these are questions we don't know, and their instructions don't tell us. I'm not going to melt your brain anymore, because trust me, we've been looking into this for a while.
But this also highlights the need or the importance of always monitoring a manufacturer's evolution in his technology.
Indeed.
Because some of the, some devices that you have been, maybe you got legacy stock of a device. It might be that they've got a new one and they just say it's new and improved. We may need to know the specifics. And it might be that some of these new changes are coming in to help with OPEN or to help with any of the other issues we've discussed.
I suppose we should go on to the questions, but Wayne, this is general. This is every night for us, by the way, with these technical chats.
Yesterday tonight has been my first time taking part in something like this. My brain is now mush.
Neil, you're welcome. I'm glad this is every 2 or 3 years. Oh.
That's not our intention, Wayne. But this is mush for all of our brains right now.
Well, it was. But let's be honest about it. Yesterday, before we started the webinar, is it fair to say that we honest to God, I could have done drugs just to wake me up. My brain was hurting so much all through yesterday's one. It was insane.
Yeah, it was a tough. I mean, I said on Discord, I sent you the part 7 presentation 4 minutes or so before we went on. It was tight.
It was tight. Yeah, it was. It was very tight. And I think the idea of a webinar towards the end of the closeout period, where we kind of summarise this, is a good idea.
I mean, we won't rush into it. We'll try and do something maybe mid to end of November.
Well, we can wing it because we've got the material. Yeah. So where people on the Discord want us to focus on, we'll develop that and then just update the slide deck.
Well, there's a great thing. I just saw it here. Andy, can I suggest that we all go away and have a look at Amendment 2 and then have an open forum for Amendment 2 on the Ninjas Discord, maybe a webinar in a few weeks to discuss further. Yeah, there's an amendment channel there. The Discord is there for you guys to use it for whatever you want to use it for. I can create a voice chat server in there. You can go in there and you can open mic to each other. You could do video messaging, or we can set up little meetings, whatever resources you guys need to better understand this. It'll help us as well.
Yeah.
Because, you guys are bringing a lot of information to us.
It's worth saying as well, we're not sitting on here saying this is happening, it shall happen, it must happen. We are 3 friends who are from different parts of the industry who have an opinion, and this is based on a draft of public comment published by the Broken Standards Institute. Thank you, John. And it was hell on earth trying to get it. And we went through this misery when the 18th edition came through, and they've learned nothing. It's almost like they're making it difficult for electricians and engineers and people in our industry to comment. It's not fair. This is our industry, and we should have an influence and a direction on it too. But if it's useful, then it's been worth every nightmarish hour and computer freeze and breakdown and wanting to throw a keyboard through a monitor and for the last 2 days. So yeah,
and we'll what we'll do is we'll watch the the information going out by the industry as well, and we'll update if anything needs to come in. We'll update via Discord or any social media or in our next talk.
Yeah, for those that don't know about the Discord, it's a kind of like a discussion forum thing. And if you want to go to if you go to the Sparky Ninja website, sparkyninja.com, just click where the webinar thing is. If you look at the top, there's a link there to Discord. So
yeah, if you look, I think there's like a video with my ugly mug, and I think it's right underneath it.
Yeah, so the link is there. So just click on that, and fairly self-explanatory. There are 3 questions which we should answer. Sean has got one there, which is sort of all combined into one. Can you clarify your opinion whether foundation earthing is in addition to DNO or DSO or actually TT? The answer is, in most cases, it's going to be in addition to the supply coming in. So it's going to be a TNCS type supply or PME supply coming in. Your foundation electrode earthing is going to be connected to that as a supplementary electrode, basically.
And the key there, John, is as well is the term they use is a bonding conductor. So this foundation earthing isn't about referencing the fixed installation to earth. This is about step potential. This is about the rise in local potentials to protect the user of the installation when they're in their island modes, etc.
I guess
which you don't really get from a crappy old pilt cable that comes in.
I guess this is the thing that we struggle to kind of identify, because what we're doing is we're putting in a stake in the ground, which we think is TT conversion. But we're actually bonding earth.
Yes, we are.
So you need to stop thinking about earth electrodes are TT, because they can be, but they don't have to be, and in a lot of cases they're not. And I mean, you could use a foundation electrode earth as a TT. However, if you're going to do that, the same problems apply, and it's got to be far away from any of the PME equipment and the cabling and all that stuff. So you could use it as that, but in most cases, it's going to be part of the existing TNCS earthing system. And then we've got, in addition to that one, will a TT style earth have a reliable reference to neutral the supply? Well, it will. That's done back at the transformer of the supplier.
Yeah,
and if
just
it's
the
going to
live
be in,
conductors.
yeah, and if it's in the island mode, then there's that switching device which connects the neutral and earth together when it's in
It
island
may
mode.
also be in here.
There you are.
Isn't it sad that I've actually put a highlighter pen on my breakers
Probably.
to highlight all the relevant bits? That is quite sad, isn't it? But there you go.
Yes,
So yeah,
maybe.
all TT systems do have a connection between neutral and earth. It's just where it is back at the supply, or if you're in island mode, it could be within your own installation. And the third one, which I just had a look to see what the wording actually states, Mark Holmes, when in island mode, does the supply's earth have to be disconnected as well as the live conductors? It doesn't say
Good question.
that that's actually the case. What it says is that in island mode, the PEI is disconnected from the public distribution network. Therefore, the system earthing of the PEI may differ, and the switching device suitable for that shall disconnect all live conductors from the public distribution network. So it doesn't say that it has to disconnect the earth as well. However, it doesn't say that it doesn't either. So it could be disconnected, or it could be remaining connected.
But it has to connect neutral to earth.
Yeah, it's connected neutral to earth anyhow, and if it goes into a TT system. So this kind of fits in with the previous question in that it all depends on your individual setup and what electrodes or things you've got in the ground, how far it is away from other concealed equipment, and whether you've got other extraneous parts coming in that are linked to other, say, TNCS type supplies nearby. So the answer is fairly complex. It could be, it doesn't have to be, but in some cases it might be desirable to do that.
Yeah, lovely.
Yep.
All right, see you later, buddy.
Just on a quick one, apologies if your brain has melted, but the reason we're doing this is to try and encourage you guys to take a bit of ownership and read and review yourself. Now, we know the system at the moment is in a bit of a state, but we've got till December to get these comments in. So if you can maybe next month take some time out, have a review, break it down bit by bit, come up with some contributions, regardless of what you think of the committees, the panels, the websites, everything around this. It would be really good if on this revision, hundreds and thousands of Sparks can put loads and loads of comments, because it will really send a message to the people on these committees that, you know, we want, if we're going to do this, help us, support us.
Yeah.
So that's kind of my bit really. And other than that, thank you very much, everybody. Sorry for melting your brains. And I think our next webinars, eventually, Dan, will be fire coding, and then we'll do the schedule of items inspected towards Christmas.
And you're going to
we'll do
emergency
an interim
lighting,
one on this.
emergency lighting as well.
Oh, yeah, emergency lighting.
And an update to this one.
Yeah.
I think that's sorted. All right. Anything else for you chaps?
No. Thanks, guys.
Paul, John, thank you for your time. All right, everyone, thank you for your time this evening. Thanks for coming in. This will be uploaded to YouTube in a matter of days on the channels and stuff. We'll put it out when it goes up. But, you know, you can carry on conversations. We'll join in on Discord or groups or whatever. Message us if you need anything. All right, guys. See ya.